Hopefully the recording will sound okay. The other time got lower audio.
Accelerated rate. And so
Okay, so this paper,
will show us for us.
Yeah, just keep wondering how come all the old papers.
There's 4 years to do 3 years.
Yeah.
That's why we've had this conversation before.
The only last time I ever do 213 section is
okay. Oh, I opened the wrong one.
wherever go against the paper. Smash it. Yeah. Okay.
Okay. So I believe the format should be the same, right? Very similar, right? 4 questions as well, right?
Yes, it's my questions.
Okay.
I go for tutorial.
It's a revision like this.
My friend went. Yeah.
Is it okay?
No.
Ah,
Like yesterday.
so this is the revision. Lol.
Careful lah, actually lah.
Oh, there
Yeah,
is?
the cloud, under the cloud.
Oh.
Oh.
But I don't know how helpful.
Yeah, I think usually for this kind of question, it should be quite doable, right? This kind of question. So I think it's more of a warm-up, right, to get you started. Okay, so how do we begin from here? So we have 32-bit, right, hexadecimal numbers to decimal. And each hexadecimal number, right, we need to show the steps to derive the answer, right, and assume all of them are signed integers. Okay. Okay. So usually what is the steps taken to obtain the decimal form?
Convert hexadecimal to binary, then convert binary to decimal.
Okay, so convert hexadecimal to binary, and then from binary becomes decimal, right? Okay, so this one they say they are signed integers. What does signed integers mean?
reading the very far left, if it's a 1, then it's actually minus.
Right, okay, so the first or the most significant bit, the MSB, right? So for here, right? Okay, what is C equivalent to?
A is 4. Sorry.
So it's 1100. Okay, then everything else is 0, right? So when we see this one is actually known as the MSB, right? Most significant bit. And the most significant bit is 1, right? It means that it's actually a negative number. So if it's a negative number, what do we have to do first? Okay, so in this case, we can easily convert it to decimal, right? So when we convert this thing to decimal, what do we get? 1100, and then right 0000 0000, right? 1 2 3 4 5 6 7 times, right? So zeros there is 7, right, times 4 zeros lah. Okay, so from here, right, this is the decimal expression already. How do we express it? This is known as the 2 complements, right, form, right? 2 complements is basically the negative number, right, variant. So how do we convert from 2 complements to 1's complement?
Minus 1.
minus 1, right? So when we minus 1 become 1, 0, 1, 1, right? 1, 1, 1, 1, all the way, right? Until the last, what do you get? 1, 1, 1, 1. Is it 1 or 0?
I have a question. If it's already like a signed format, why do we need to take like the intermediate steps to get to decimal?
Yeah, it's last one. The last one should still be 1.
Yeah. Show the steps sequence.
Okay. Sorry.
Okay, so it's plus 1 or minus 1 or what?
The last one should be -1.
The last one should be 1.
Yeah.
Okay. So once you have it like that already, what do you do next?
Everything just switch over. All 1 becomes 0.
Okay, so this is the 2's. This is the 2's complement, right? We need to convert it to the okay, so all we do is just invert, right?
So from that step to this step, you add 1, is it? So where from this one get this complement?
Let's break it up into binaries. Everything what you have are all the 1 and 0, so you combine it upside down.
Actually, I wrote a bit not so correct. This is first complement. This first complement. This is actually 2's.
Shouldn't the far left should be second complement, then the next one?
Yeah. Like that. Yeah. I label it like that. This is the binary. Okay, so to go backwards, right, you just what? Just invert, right? Right, once you invert already, then you plus 1, right? So normally this is the way to do it, right? Yeah, so basically you're just going backwards. You minus 1 and then you invert. Yeah. Another way is actually you can invert. You can invert, right? Invert here. And then you plus 1 also can, right? You can do that also, right? What do you think? Actually, you can, right? You can just invert and plus 1. Whether you go forward and backward, you can actually do either way. You don't have to minus 1 and then invert. You can just plus 1 and invert. It's actually the same thing. Yeah. Yeah. So it is always invert plus 1 if you go in either direction. Yeah. Right. If you realize, right, if I invert, what do I get? 0, 0, 1, 1, right? 1, 1, 1 all the way, right? But this is not the first complement, right? This is definitely different. Right? Then after you plus 1, right? Then what do you get? You get 0, 1, then 0, 0, 0 all the way, right? Yeah, so this is the binary value already. So if you want to convert between the binary value and 2's complement and 2's complement back to binary value, you can just use the method, right? Just invert and then plus 1 can already. Okay, from binary numbers, I believe it should be straightforward, right, to convert into the decimal, right? So for every every value, right? Okay, every value represents a certain magnitude, right? Yeah. So in this case, this 0 represents 2 to the power of 0. This is 2 to the power of 1, etc. Right? 2 to the power of 2, so on and so forth. Okay, so this is 2 to the power of what? Okay, so this should be 2 to the power of.
31. Sorry.
So total there are 32 bits, right? Right? If total there are 32 bits, this is the 0th bit, right? This should be the 31st. So this is 2 to the power of 31. So here should be 2 to the power of 30. Okay, so the answer is actually, what's the answer? So overall in the end, what's the answer for this one? Equals to?
Oh, goodness. 107.
2 power 30, right? But negative 2 power 30. Okay, don't forget the negative sign because it's a negative number, right? Mm-hmm.
The binary on the far left, when you know you convert it from 0 to 1, 1 to 0, is the far left at the end like still 0 or 1? Can't see.
The right side one is 0. Yeah, so I write a bit nicer now. Yeah. So this one is actually 1 1 0 0, right? 0 0 0 0. Then become 0 0 1 1 1 1 all the way. Right. First complement. Then become, right, you minus, you invert everything, right? Yeah. Okay, so I hope this should be easy to understand. Okay, so for the second part, right, 7, what is the binary value of 7? Okay, so it's just 1 1 1, right? 4 plus 3, 4 plus 2 plus 1, right? Okay, so E is 1 1 1 0, okay? And then 0 0 0 all the way, okay, until last one. Okay, so this one, right, what form is it? Is it in the binary number or first complement or second complement?
Oh, binary. Right, yeah.
It's just binary, right? Because the MSB is, right? So this is actually a positive number, right? Because MSB, right, equals to 0, right? So what do we need to do now? So we just convert it to decimal, right? So from here, how do we convert to decimal? We just add everything, right? To the power of 30 plus to the power of 29 plus to the power of 28 plus to the power of 27, right? So this is 30, 29, 28, 27, 28, 6, 25. Okay. Okay, there's another method you can do. You can directly convert the hexadecimal to binary using this format. Okay, so this one is actually what? 16 to the power of 0. Okay, so this should be 1, this should be 2, 3, 4, 5, 6, and 7. Right? So we know E is actually what number? 14, right?
Yeah.
So we can do this. Right? We can just do this. 14, right, times 16 to the power of 6, because this is on the, right, 6th position, and then this is on the 7th position. So 7 times, right, this is the 7 multiplied by 16 power 7. So these two should be equivalent. If you plug into calculator, you should get the same value. Okay, so you can do either way, right? If you're not sure, you just do both way and then you get the same answer, then you correct. Right. Okay, this is just 4 marks lah, so shouldn't spend too much time on it.
Question. If it's if the 7 was an A, right, then it'll be negative. Then we cannot do the straight.
Yeah, we cannot just convert. Yeah. We have to.
And it's 2's complement.
Yeah. We have to do like part 1. Okay, so the next part asks us to convert the following 16-bit hexadecimal numbers to decimal, right? And then for each hexadecimal number, show the steps to derive the answer. Assume all of them are signed real numbers with 4 fractional bits. So it's Q12.4 format. So what does that mean? So total is 16 bits, right? Okay. So fractional bit, so where's your fraction? Where's your dot? It's actually here, right? Correct. Here is your dot, right? Here's your fraction, right? Okay. Okay, so the dot represents like basically here this number. So this number, right, represents your fractional bit lah. Then this is your whole numbers, right? Right, whole number lah. I just write it in full. Okay. So the first one, what do we do?
Put the whole numbers first. This is signed.
First thing is yeah, we need to convert it to binary, right? So originally it's 2's complement, right? So when we actually convert it to this 2's complement, it's actually 1 1 1 1, right? Actually I can write the full thing lah. 1 1 1 1, right? 1 1 1 1. 8 is actually, what is 8? Okay, like that. Okay. And then after that we convert to binary, right? So when we convert to binary, what happens? Okay, end up you should get 0 0 0 1, right, at the end. Okay, I'll write the full thing again. Okay, so it's just 0 0 0 0 0 0 0 0 0 0 0 0 and then 0 0 0. Wait. So it's just 1 0 0 0 lah. Yeah, is this correct? Correct. Can. Okay, so right, this is actually your this is your 2's complement, right? Okay, this is your binary. Okay, I just jump right from 2's complement become 1s, then become binary. Okay, you never see the 1, but I just jump to binary. And from the binary, okay, so this one, okay, so we know the decimal place is here, right? So it means that this one should be 2 to the power of 0. Okay, but everything else is 0, so we actually don't really care. So this one should be 2 to the power of -1. Okay, so this is 2 to the power of -1. It means that our answer is actually just equals to negative 2 to the power of negative 2 to the power of -1, which is actually equals to negative 0.5. So this is our answer in binary. Okay. Okay, so now we look at this as well, right? This one, there is a positive number, right? So it's just 0 1 1 1 0 0 0 0, right? What is C equals to? 0 1. No, it's definitely not 0. It's 1 what? A is 10, B is 11, C is 12, right? 12 is 8 plus 4. So like that lah. Okay. So from here, right, we can immediately convert, right? Remember, this is 2 to the power of -1 to a -2. Okay, this is 2 to the power of 4, right? Okay, so the answer is actually 2 to the power of 6 plus 2 to the power of 5 plus 2 to the power of 4 plus 2 to the power of -1 plus 2 to the power of -2, right? So what will our answer be? Correct? Right, actually what is this equals to also? It's equals to 7 times 16 to the power of 012, right? So 16, right, plus C is actually, just now we went through like 12, right? Times 16 to the power of -1. Okay, so I think the answer should be the same as well. Yep, okay. Yeah, so you have two methods. For those positive one, it should be easier to do, right? You don't have to go do the clue supplement. Okay, so we can go to the next. So this is 10 marks secure already, lah. Okay, for the exam. Okay, now look at this. Evaluate the following expressions and then convert their results to IEEE 754 single precision format. Right, give your answers in hexadecimal format. Okay, so in this case, you have to remember what is actually the IEEE 754 format, right? So what is the format? Can anyone tell me? What component do we have first? Okay, so let me write out first. Yeah. Okay, so the sign component is how many bits? Okay, so it's just 1 bit. I'll just put a bracket with the number of bits. Okay, sign bit followed by no. Exponent. Right. So exponent is actually supposed to be for what? For your 8 bits. For your what? For your magnitude. How big the number is. Right. So your number can range from if I'm not wrong, it should be somewhere along the lines of 2 to the power of -2 to the power of -126 to 2 to the power of 128. Right. Later I'll write it down. Okay. So it allows you to get from -2 to the power of -126 to 2 to the power of 128. Can anyone double check for me whether this is correct? Okay, and last but not least, we have the actual numbers itself, right? What is it called? Okay, mantissa, right? How many bits is this? Okay. Okay, so I hope this one right, you remember it lah, because it's a very important component, right? Okay, so let's head on to the question. 7 minus 3, okay, divide by -2. What answer do we get here? Right, not this is just binary first. No, it's just in decimal form. So what is this answer? Okay, -2 times 2 to the power of -127, right? The bottom one is actually okay. So how do we determine our exponent? How do we determine our exponent? Okay, remember our exponent, right? When it's 0, 0, 0, 0, 0, all the way until 1, right? It's actually what? 10 to the power of negative 127, right? So actually, like for example, if a value x, okay, is actually minus 127, let me see, yeah, okay. So it's actually like this, right? Then equals to, right, your magnitude here. So in this case, your magnitude, so maybe how I explain this? Okay, so in this case, basically just remember this, 127, right? Is actually equals to, right, log base 2, right? And then this is your magnitude, right? Your number, number 2 to the power of something, something, something. So in this case, this is actually 2 to the power of, yeah, so it's actually 2 times 2 power negative 127. And in this case, the answer for this is actually negative 126, right? And x equals to 1. In this case, this is the number that we know, right? Need to be represented in the exponent. Okay, so how do we write it in our sine, exponent, and mantissa? It's actually, sine is actually 0 or 1. 1 because it's a negative number. Exponent is actually, it's also 1 also, right? Right, because x equals to 1 ma. No, you need to find x. X is actually your exponent. Because the for the exponent, right, it actually when it's 0, 0 all the way to 1, right, it's actually the very, very most negative number. It's the smallest number. If exponent is actually halfway through, right, then it's actually 0. It's actually representing your whole numbers. Then you got more, right, become 127, 128, right, to the power of 128. Yeah. Okay, so exponent is actually just 0, 0, 0, 0, right? 7 zeros are 1. And for your mantissa, right, how do you calculate your mantissa? Okay, for it, you just need to plug in, right, your number, right, 2 times 2 power of negative 127 divided by the exponent, right? So the exponent is actually 2 to the power of x minus 127. 127. So your x is actually, right, you get 0 lah. Sorry, not 0, just let me see. Actually this is just 1 lah, but it's the same there. Let me see how to. I think it should be a minus, right? This minus this, right? Should be a minus or divide.
Shouldn't it just be one?
I think should be this one then minus 1. What is the formula again to calculate? Should be minus 1, right? Or yeah. Anyone remember how to do the Mentisa part? Just to confirm the format. Oh, anyone got idea? No? Not really. Cannot Mentisa.
Between 1 and 2, but I do not know how to get the value.
Okay. Let me see. Last time I remember it shouldn't be too complicated. Maybe give me one moment. Okay, I'll double confirm the lecture slides. For this one, right?
Oh.
No, that's definitely not negative. It has to be positive. You can use the formula, the x minus, right, 127, that one. Yeah. Let me try again. Okay, so let's say we have a number, right? Okay, we have a number, for example, number A. Okay, first step is actually to determine the what is the first step to what is the first step that we need to do? Yeah, sign bit, right? Check for sign. Okay, whether is it positive or negative? Huh? Second step is the exponent. Right, so you can do it this way, right? So x is supposed to be your result lah, right? This is actually your exponent value equals to, right, log 2 of your, right, log 2 of your number, right? Okay, log 2 of your number A, right, plus 127. Okay, but in this case, you floor it, right? Floor it basically means just take the lower number, you delete all the decimal point. So you can just remember this lah. Okay, so now how do we compute the mantissa? We actually third step. Okay, so this is the third step. The third step to calculate the mantissa is actually your number. Okay, multiply by two. Let me see log. Yeah, correct. So 2 to the power of x minus 127. Let me see. 127. Need to have a negative lah. Minus 127 like this. Right, it's actually known as just same as x times, right? 2 negative the floor log 2 a like that also can. Right, and then minus 1 in the end. right? Because your Mantissa actually already adds 1 by itself. Okay, so you want to try some values and practice first. We spend a bit of time to practice this to be very confident so that it takes you only 3 seconds to do. Cannot really lah, but yeah, you get what I mean. Okay, let me get the converter so that we can double check our answer when we do this, and then we use this method. Okay. Okay, let's try. Okay, let's try -17. Okay, -17. Okay. Yeah, -17. Our sign bit, this is 1, this is 8, right? And then our Mantissa should be 23. Okay. For sign bit is just 1. Exponent. So our exponent is actually just right x. Okay. So this is calculating our exponent. X equals to log 2 base, right? Log 2, right? 17, right? Plus 127, which is equals to log base 2 is of 17 is actually 4 point something, right? So 4 plus 127 we get 131. Okay, so 131 we put here. So 131 should be. Actually, I got the answer. Okay. If you haven't reached where I am at, then try to do yourself first. Then you just double check whether you're correct. Okay. Okay. Actually, I should put a like this, right? It's a magnitude only in this case, right? Right. Maybe if you're confused. Okay. Able to get the value? Need to top it all off. You can actually write the hexadecimal expression as well. Okay, so these are all the steps and this is the answer for question for the number 17. Okay, I didn't really write the working for the Mantissa part. Okay, let me write it. I just calculate. Able to get it?
I'm not sure whether halfway got wrong. I followed this.
You got this, right? Oh, okay, can. You can times this one. Then this one should represent just one only. So let me see.
I'll change to binary.
Yeah, now change to binary. Yeah. On the calculator, what you can do on this is decimal value, right? 8.12896, right? Like that. You change to hex. Or you got 88
Yeah.
Maybe
like,
there's
I don't know whether
0.0625 times 2 power. No, okay. This value.
oops.
Not somewhere wrong.
Oops.
Okay. Yeah, that method is also possible. So it is easier to help you convert to a more understandable Mantisa. So I can show you the method. Maybe you try with a different value, okay? Let's see what value should we try. Let me go and compute some value, okay? Oh, sure. Have fun. Let's see. Okay, this number will seem very fun to you. Okay, are you ready for the next number? Okay, the next number is 123.123124. Okay, the first step is sign bit, right? Sign bit is 0. Okay, exponent is actually, what's the formula for the exponent again? Right, x equals to, right, log 2, right, 123, right, plus 127. Okay, remember for Mantisa, what do you do? Right, referring to our format is actually multiply by the negative exponent, right? So it's just 123.12124 multiplied by 2 to the power negative, right? Okay, minus 1 equals 2. Okay, another method is, we can multiply this number, this number multiply by 2 power 23, because Mantisa got 23 bits. Okay, so once we multiply by 2 power 23, we get some big value, right? And then we take we just take the floor of it, right? Oh, sorry, not take the floor, we round it. round it. So we want to round it up, round it down, so that the accuracy is closer lah to the actual answer. Okay, this one we just convert it to, right, either whichever you like lah, whether binary or what. So from the decimal, we can convert it to, right, hex also can, right, or anything you like. Okay, but in this case, let's just convert it. Yeah, I can just convert it to, let me see, 1, 2. Yeah, I can convert it to hex first. 7. Okay, but this one is because it's 23. It's not 24 bits. So you need to double check. You need to be careful. Yeah. Okay. So when we add everything together and then we realize the last bit, right, correspond to this first bit of 7, right? So what happens is actually so originally is 0, 1, 0, 0, right? So this is actually just 4, right? So just 4. The next one is, okay, this one over here. So it's just 0, 0, 1, 0. It's just 2. Then 1 in front of the 7, because 7 is 0, 1, 1, 1, right? Then you need to make sure this is the 1. So we have 1, 1, 1, 1.
It's not F09, it's FOA, right?
And this is, sorry, this is not 7, right? It's 8 if I'm not wrong.
It's FOA.
Oh, F, yeah, F.
No, it's like
F.
I'm the answer.
the top.
Where?
This one, it's not 9, it's 8.
It's not 9, ah.
Yes, it's 8.
Oh. Okay. Oh, did I type wrongly here? Yeah, the 8 is correct. Let me see. Let me see my decimal value. Oh, I put. Oh, let me double check again. Let me double check my working. How come is? Yeah, the answer is correct. Your answer is correct. Oh yeah, 6. How come I end up with 5? Okay. I don't know. Type calculator also can type wrong. Okay, so it's F63FOA. Yeah, I just bring down only lah. Yeah, so you can, this is the actual answer for this. Okay, I think got a few more examples. That one is to make sure you can do every single thing, because now you can do any number, right? But there are certain cases where the numbers, right, are illegal numbers. Okay, so let me go and get them for you. Let me see. Where is my thing? Okay, hold it. Let me bring this over first. Okay, so now you all know how to compute the numbers already, right? Properly, right? Hopefully. Okay, so now what happened if we have this number 8 times 2 to the power 126? What will happen then? What do we do with this number? How do we convert to? Okay, so 8 is actually, this is equals to 6, 7, 8, 9. Okay. So can you all convert this to your IEEE 754 standard? 2 to the power of 129.
That's a range. It should not be possible.
So what's the value?
Now,
So don't bother go and calculate because actually it's outside the range. the reason why I went through this is so that your when you see this during exam, you don't go and calculate, then end up right, you realize actually it doesn't work. Right? You must be able to recognize what is the range of this. What is the range of this number? Okay, the smallest exponent or the smallest magnitude for normal number is actually 2 to the power of -126, right? Okay, that is the smallest already. What is the largest? Are you sure it's 127?
6.
So it's supposed to be 127, 126, 127, or 128. Hmm? Oh, don't know the answer. Want me to tell you the answer? Just now I say already, ma. 2 power 128. So if it's 2 power 129, can or not? Cannot, okay. If it's 128, can or not? Can still express. Okay, so actually this is this is actually equals to, let me see where the value here. Okay, so this is actually equal to, right, for this single precision range is actually plus minus 1.2, right, times 10 to the power negative 38, right, to 3.4 times 10 to the power 38, like that.
What is this? I don't understand.
These two are just the same.
To the power 128 is 3.4 times.
Yeah, it's just 2 to the power 128, 2 to the power negative 126.
Yeah, I see that.
Okay, so just a quiz again. What is the smallest number?
2 raised to power of -126.
Okay, someone else answer. 2 to the power. Then what's the largest number?
2 raised to power.
Okay, so can okay, very very clear.
Yes, sir.
You just remember the 2 power of 126, 128. That one easy to remember because this one you use calculator, you can calculate one, so it shouldn't be a problem. Yeah. Okay, so actually there is something called the denormalized floating point, right? So denormalized floating point. So now we know how to calculate normal numbers already, right? All these are normal. So within this range is actually normal numbers. There is another thing called the denormalized floating point, right? So denormalized basically means that all of your exponent bits are all 0. You all know that your mantissa, right, is actually here, right? Can see or not? So here is actually 2 to the power negative what? How many bits are there?
23.
So 23 lah. Why? Because it starts with -1, so it should end with -23 lah. Okay.
Oh,
Okay, but then what you realize is if we have this, it means that we can actually go below this range. You see or not? This range is actually until 10 to the power -38, correct? We can actually get even lower number than this. Yeah, we can get actually lower number until, right, lower until Okay, where was my thing already? Oh, it's here. Yeah. Lower because we can continue to fill up the mantissa, right? We can continue to fill up. So as we put here, right, it becomes, so basically what happens is it becomes smaller and smaller and smaller. Understand, right? Okay, so originally, so now let's say if you want to convert from, let me get a good number, like 4D like that. Mhm. Okay, can you give me the can you calculate for me? How do I get 1.09 times 10 to the power of negative 38? Do you realize that this is actually smaller than just now what we said? 1.2, right? Times 10 to the power of negative 38, right? 1.2, right? That's a small number, right? This is even smaller. Okay, so how do we get the right mantissa for this one? Okay, so we know in this case, right, it's actually smaller, right? So when we do the log, so we do log 2, right, 1.09 times 10 to the power of negative 38, what do we get? So just now was x equals to, so what should we get? This one, well, by right, for our formula we should get 1, right? So you have to be very careful. Right, actually x will become 1, but our exponent is not 1, right? It's 0, right? Because it's less than the value already, right? So it's actually illegal, right? So you need to make sure that this number is less than, right, 2 to the power of, right, negative 1, 2. Smallest numbers is what? 6, Okay, this is smaller. Okay, so this one cannot. So our number is denormalized already. Okay, so from here, right, so we know our exponent is zeros, right, all zeros. So how do we get this value, right? We just need to, right, we can do this lah. Let me calculate. Times 10 to the power negative 10 times 2 power of 23, right? Yeah, correct. Let's see. Oh yeah, correct. Let's see. Did I correctly? It's correct, right? 19, yeah. Okay. One, two, 6, is it? 2 power. Oh, I never correct. Well, let me double check the. Oh, oh yeah, I forget to add. Yeah. 1, 2, 6. Yeah. Okay. So we know that the smallest number is this one, right? Okay. I don't know why I could. Okay, so to calculate the mantissa, right? Okay, we times 2 to the power 126. We should get 0.9 something, right? Right, 269,449, like that. So from here, right, we need to determine the mantissa itself, right? So what we can do is we can multiply by 2 to the power 23. Okay, so this is to normalize the number to make it between between 0 and 1, because right, denormalized number, right, the floating point, right, basically the mantissa itself, right, you don't need to cannot plus 1 anymore. For the normal number you can plus 1, but for this floating point there's no more plus 1 anymore, right? So root 1 to, sorry, which one? This one, the cancel part, is it? This one yeah, because this is to normalize, because this is the lowest number, right, smallest number, right? So you multiply by the so-called the power of the smallest number, right, you get back to a normalized value. So this, right, you multiply by 2 to the power 23, you get 777. So we just round it lah. So what we should get is 777 8,500, and then we convert this into decimal, not decimal, sorry, hex lah, or whichever you call it. So in the end, our number should get x times 0076b0c4. This one? Oh yeah, sorry, and that's times 2 to the power 23. This is just to calculate the mantissa. You can do any other method. This way, right, you can just find using the 2 to the power -1, 2 to the power -2, whether it fits inside or not. Yeah, either one lah, whichever way works. But in this case, to make your life easier, you can just times 2 to the power 23, because mantissa itself is 23 bits long. So that can be the range. So in this case, you can get a value lah. So this is your denormalized number. Okay, so before I let y'all go through, maybe practice like maybe 1 or 2 more practice numbers, right? Maybe let's recap everything again, right? To get back to become more familiar. Okay, so first thing is we have the number, right? We check for the sign, right? Whether is it positive or negative. But let's say if the number is too small or too big. Remember what's our smallest value again? 2 to the power of? Right, -126. Our biggest number is? Okay, okay, so if it's smaller than this, it's denormalized. If it's bigger than this, what should it be? If it's bigger than 2 to the power 128, it should be what?
Just
Not a number or infinity?
Yeah, right. Plus, minus, infinity. If it's much smaller than your denormalized number, what happened? Not a number. Cannot calculate lah. Yeah, exactly. Okay, so let me see whether I can get a not. I don't think I can get anything. Oh, actually I can. Right. Oh, actually, sorry. Maybe I'll clarify this. Okay, so if it's too less, right, it's denormalized. Just to confirm, not a number. It means that n, right? Yeah, not a number. Yeah, correct. Exponent and mantissa all ones. If it's infinity, infinity is your right, your mantissa, all zeros.
Not a number, the mantissa can be a non-zero, but the exponent have to be all one.
Oh, yes. All ones. Okay, basically, exponent has to be all ones lah. Okay, but at least one mantissa must be at least one bit should be one, right? Yeah, okay. Good thing you pointed out. I just realized that. I also didn't know this. Okay, the infinity, the sign can either plus minus. It still can be plus minus. Okay, so for infinity, right, exponent all ones, mantissa all zeros. So it must be that condition, right? And positive and negative only. For not a number, right, exponent is all ones. Mantissa, you need at least one bit is one. So it's basically a infinity, but mantissa must have at least a one. Okay, and then your sign can be anything lah, right? Whether positive or negative, right? Doesn't matter. Okay, so this is like the extreme case. Sometimes the exam give you this because they want to test your understanding. Okay, hard to remember, not easy remember.
Was this in the notes? No?
It's in formula sheet lah.
It's in the formula sheet.
Yeah, the first page of formula sheet.
Oh, then why remember for what?
Just to point out that we can know the understanding.
Oh, okay lah. It's actually here.
So that's what
All I see is 0, 1, 1, 0.
Yeah. I remember I go and like study this. Then after that I realized, oh, it's in the appendix. Okay, since got yeah, it's which actually is really inside the thing, so you do have to don't worry so much. Okay, so let me give you all a number then you all see whether you can try to solve it Okay, let me see what interesting thing I can do. Give me one moment though. Okay, so let's try negative 3.4, right? 0.282 to 3.46639 times 10 to the power of negative 10 to 38. Yeah, it's a very interesting number. Tell me, then you have to try to calculate for me the hexadecimal value. I just want to give you all the very funny numbers. Okay, because if it's a normal number, I think y'all can do it easily, right? Okay. Or you want me to give you one normal number? Got 4 numbers already, actually 5 numbers already. Let's just practice all of them. Yeah, all of them have a different type of number to understand. Yeah. So if you can do all of them, means you should be set already, more or less. Yeah. You can try all these weird numbers. I'll give you the answer like slightly later on.
Forgot what was it on the 10 of the week.
Just now was what? 2 to the power of negative what?
No, I know the whole 2 to the power of negative 1 to 6, then 2 to the power of 1 to 7.
1 to 8, 1 to 8.
1 to 7.
The largest is 1 to 8.
But I don't know what's the number for that.
The denormalized one. So what do you think it is? That's an interesting question, right? What do you think it is?
Wasn't there like 2 different types?
That's operator. To the power of whatever is whatever.
Okay, so I give you some mercy, right? I write the range for you. What number are you at now? The third one. Okay.
The second and third is cannot do one, right?
Can do.
Third is
Can do.
NAN and infinity.
Yeah, close, but not exactly.
Oh, there's a minus sign.
Everything else is positive because I don't want to. Actually, there's no difference whether positive or negative. Okay, so while you're doing, I give you all a bit of clue, right? Okay. Aha. Is this better? Okay, now you're asking that question, right? I give you the answer now. 126 is the absolute minimum. Okay, in between is denormalized. Nope. Yeah. This is the bare minimum already. This is the bare minimum. Wait, let me double confirm. Wait.
Doesn't that mean those two?
Oh.
Yeah, that's why. When I was looking at it, the numbers are way off.
Sorry. It's supposed to be the other way around. Yeah, give me 1 second. Then not correct. Okay, but past this point is actually denormalized lah. Yeah. Past. Oh, sorry. Yeah. It's actually yeah. Yeah. Okay, like that. Yeah. Sorry, I a bit.
I don't know what's going on anymore.
I haven't do the question because I actually don't know how to do the part. I forgot how to normalize something. Was it times 2 to the power of 126?
You multiply it by 2 to the power 10.
Oh, wait.
1 raised to the power 1 to 6. Then you multiply 2 raised to the power 1 to 3.
Well, I only did it once only, then I remember it.
No, that's the mental circuit.
Yeah, it's cemented.
Oh yeah, this is then correct. I miscalculated, but yeah. Okay, this one is this is the denormalized part. Okay, but basically it's just by the Mantissa number, by amount, right? 2 to the power negative 23. Actually, that's it.
You get
126 plus 23. I just add only.
okay.
Yeah, this is the absolute minimum you can get. Yep. So you want to check answer already? Halfway done. You got this answer? Wait, anyone haven't do question 3 yet? Part 3 yet? Then I don't tell you the answer. Yeah, I tell you the answer then spoil the surprise. But you got infinity, right, for the second one? The second one should get infinity, right? Because it's larger than 128. 2 to the power 128.
What am I calculating?
What number do you get?
What number? What am I doing?
You have to check whether it does it exceed or not.
I don't know what's happening.
If you divide by 2 to the power 128, right? The number divided by 2 to the power 128, you actually realize that it's a multiple of 5 or something. It's actually larger. Yeah, it's larger than 2 to the power 128. So it has to be infinity already. It's too large.
I first one wrong now. The second one also wrong.
The first one, there's no trick. There's no trick. It's just
within the range.
it's within the range.
Yeah.
So you just calculate. It's just a bit more tedious, right?
The first time I did it, I forgot that there's a negative sign.
Oh, same.
Oh.
I thought it was outside the range. And there's a negative sign, and I was like, oh, that's why.
What's happening?
My brain was not waiting.
It's not quite fun, right? It's good that you all get it wrong, right? Good that you so you all know like which part you still don't understand yet. That's why I purposely count at this type of numbers.
I feel like every time when we do finish everything, there's a chance we'll forget the negative. Then like
Yeah, like you look up and you're like, shit, the negative.
yeah.
No, that's why the first thing I write during
Is
exam
the
is
sign,
sign, right? Then exponent,
Yeah.
right? 8, and then Mantissa is 23. Then I put in first. So it's 1. Then I work with the exponent. Once I work with the exponent, I write the Mantissa. I always do it this way. So I usually think that the way won't go wrong lah. So yeah, you just work it one by one. Remember the step, right? Step 1 is find the sign first. It's always the sign. Whether the number is infinity or not, you put the sign first. Because sign infinity also has sign also. Except for not a number lah. Yeah.
So basically, after you get like the Mantis, like you get exponent.
Right, that's inside the number. What do you mean?
This is the
What, this one is it?
Yeah, it's I just take that times 2 to the power of negative bracket 255 minus 127.
You that behind it all times 10. Okay, then 10 to the power of 38, right? Okay, so this number you want to get you need to get exponent first, right? You got it already?
Yeah, 255.
Yeah, correct, right? So 255, right? So now you want to get your Mantissa, right? So Mantissa is this step, right? Over here.
I put the whole step here.
This one.
Yeah.
Yeah.
Look again. 2 power negative bracket 255 minus 127 bracket.
Yeah. Okay.
That's that. This is what I get.
Okay. Okay, then you equal. Then you got the number, right? Yeah, then you need to times 2 to the power of 23, right? Correct? Then Mantissa is 23, right?
Maybe that's the one I've been getting lost.
You didn't times 2 to the power 23, right? Just now I went through the step here,
Why do I get
Because
negative
that
x when
this times what? Yeah, bottom right there.
I leave it here first.
Times 2 to the power of 126. On the right side.
Oh, wait, where?
On the right
This
side.
one?
No, yeah.
Yeah.
I still get the idea between 23 and 126. I mean, this is the normalized. Yeah.
This is the norm. This is your this is your yeah, but you still times 2 to the power 23 also. Whether it's denormalized or normalized, you still times 2 to the power 3. Yeah, but make sure for the normalized number you need to minus 1 first. Yeah. So that's why, right, you denormalize cannot do it because there is no minus 1. Sorry, I go back here again. You want to see the question.
0.5. When you find what 2 to the power negative 1 over stuff.
How could you times 2 to the power 23? I go back, go to you.
It's plus shit.
What happened to your numbers?
Isn't that supposed to do that?
No, you should have a big number. This number times 2 to the power 23. Yeah. It's also minus 1 because it's a denormalized.
If exponent is mine, it's
Actually,
a
like that.
negative, then what does that? How does that?
It's actually so weird like that.
Then how come we lose?
No, because it's minus 1.
Excess 1 2.
So like that, just times 2 to the
So
power.
you just 1 to 0 minus.
Yeah.
It's really normalized.
number.
So that number
so it's
was
1 to 7 minus 1. So we can 1 to 6. Because it's excess, 3D as an excess. So it's actually 1 to 6.
I was going to leave this to the calculator. Let me do this.
now you can go back.
So let's see it.
This one if you do minus 1.
Yeah, it's the drop minus 1. Then this is minus 1.
Because this number is a bit larger than 2 to the power. A bit larger. No, it's not 1. You times this one, right? Times 2 to the power 23, right? Yeah, correct. You put a negative number, right?
I put negative number.
Okay, times 2 to the power 23. Then you get this number. Then this number, right? You do, right? You realize that it's actually 7.
How do you get this? I thought you were constantly keep getting minus something.
No, because it's supposed to be this number. It's not get this number. If it's less than 1, then it's still not alive.
Oh, the first question.
The first question.
Yeah, and was. Yeah. This is not the answer. So what's happening? I don't understand. Yeah.
So you times 2 power 1 to 3. What, 255? It's also times. So your exponent is what? 255, right? You manage to get 255?
Oh, so I must add first.
You must get exponent first. So this one, right?
Oh.
You do log. Not base 2. You can consult us. Spencer, I think you log it. So where you're at now?
Let's look back denormalize how you calculate the matrix again.
Okay. I think it was over. Is this one, right?
Yeah.
Okay, for the denormalized number, you multiply by the smallest number, right? 2 to the power 126, right? 126, yeah. It's to make it normalized, right? Normalized to the between 0 and 1.
Oh wait, I multiplied by the wrong number. That's why I'm not getting the answer. Yes, that's good. See you. Bye-bye. It's very to normalize, right?
I just started it right now.
Go. That's it, that's the normalization. You disappeared.
The fourth one is
Fourth one is
exceed, right?
fourth is like you need to normalize it because it's.
Is it still under denormalized? Because this is the max. Looks like out.
So you need to normalize it first.
Is this out or in? Is number 4 out or in?
Number 4.
Number 4 is out, right? Like, it has to go through that process, right?
It's basically it's out. You have to
Yeah.
You have to normalize it and then do
first.
the Metesa part.
Correct.
That's how you do number 4.
Yes, correct. Because it's negative 45. Your maximum was
Yes, sir.
1.4 times 10.
No, it's inside. It's within.
Huh?
It's denormalized number. You check. It's inside here. It's inside.
It's barely
But we
inside,
need to-
right?
Barely inside.
Yeah, that's
That's the
why.
point.
I don't get it from this.
Let me
My
put
sign
this
is
on again.
my
Everything is 1.
Exponential is all ones. Then when I do the thing, I just write 0 here first. I mean, yeah, like it's supposed to be 3 ones and everything will be 2 1. That's the section. Yeah. So I was wondering how is it F then is 0 1 1 1. Because you need to like take this.
Yeah, let me go and write it and double confirm again.
Online.
As in, it's common correct, but
I'm trying to get
How
the
you
full
survive
point
this?
zero.
Okay, you know calculator, I got one more.
We got one more.
Alright, yeah.
Can I borrow? Thank you.
Nice.
I like my friend who's doing final today. I didn't realize.
oh, it's actually exponent is 254. Exponent is 254, not 255.
The first one, right?
Yeah.
I wonder why we didn't get it.
Actually, exponent cannot.
It's correct.
Huh?
It's correct.
I think.
It's correct. Like how I did is I take one here, one side, then this is my.
You minus 127 or minus
then this is
126. You minus 127 or minus 126. Supposed to be minus 127.
Yeah, minus 1 to 7. I always been doing minus 1 to 7.
Okay, wait. So this number, right?
1 to 6.
So
I use
3.4028234669 times 10 to the power 38, right? So this one we need to.
times 2 to the power of negative
It's
bracket.
very
So I solve it as A
Yeah.
first, right? Log base 2A, right? Minus 1 to plus 127, right?
Yes, plus. This is the exponential. You plus it. 1 plus 1 to 7, you get
You got one, right?
Plus 127.
Is it one?
255.
I don't know, bro.
No, you need to floor it.
Plugging numbers.
Yeah.
Mine's ready to
Cannot, you must floor it.
But if I up it, I get this.
Cannot up, must floor.
Yes.
You don't know what I just said it. No wonder you get 255. Actually, 255 is either infinity or not a number. You must floor it. What is floor, right? It's basically just deleting the decimal places. So it's 254. Yeah, 254. Cannot be higher because if higher then you. There's no wonder you cannot get. So that step must be very careful. Okay, only for calculating exponent, right, must take the floor. If you calculate Mantissa, right, you round. Yeah, so round, whether you can round or round down can, but for Mantissa for the exponent must be floor. That means you must delete the decimal place, even though it's 99999. That's why I test this. That's why I test this question. I test this number. It's meant to be difficult in the first place. It's those ages, right? Giving all the ages. Like I give you the age only. But this one is good. If you know how to do this, if exam come is easier, you sure okay one.
I don't know. The fourth question is tripping me out.
The fourth. I give you like the age, right? Like one of the nearest.
I divided it on the calculator and I was like, it's barely in. Let's make this
So you like my questions now?
For the
First question.
if the last one is
So what was the problem?
Yeah.
not a number, then the Mendesa says non-zero. Like it should be 1. So do I need to calculate that or I just can put like 00001?
I don't want to read.
Okay, so what is it supposed to be? Is it supposed to be Mantissa? Sorry, is it supposed to be not a number or infinity or what?
No,
Just take
after
it slowly.
it's out of the range.
Okay, so let me type it in. Then we see the answer. Actually, I forgot the answer.
Okay. I'm still doing third question. I forgot how to do
Is it
The
not a
answer is
number?
actually 0.
What? So it's not a number? So it's not a number.
We did the scientific calculator with algebra 3 times. I got 0. I was like, this has to be wrong.
Okay,
Like the fourth one, right?
yeah.
Dude, I
The
plugged that
fifth
in
one, the
algebra
fifth one.
3 times.
No,
The last one,
The last one.
Yeah, that's not the fourth one.
The fourth one is correct. It's actually a number. You can calculate. Right?
Okay, I've been messing something.
That's why I purposely test this one.
The last one I don't understand.
The last one is too small already. So actually, I think if you put not a number or you put negative infinity, actually, I guess you can put negative infinity or you put 0 should be correct. But I think you put 0 is the best answer
Keep forgetting.
because it's too small for the computer. Right? So you can if the computer take it as 0 also can.
I keep forgetting why do I need to find 2 to the power 23.
Yeah, because your normalized number, right? You need to multiply by 23 to get the Mantissa. Yeah.
I got that 0.9 thing after I dropped that 255 to 254.
You cannot get 0.9 though.
No, I'm saying I got 0.9 because remember
Oh,
that.
you minus 1, right?
Yeah,
Oh, yeah, correct.
I see all these numbers.
No, I'm going to the
You want any more hard questions?
Yeah, this is the first question. I don't know what's the issue.
I need to make sure this is right.
The this one is okay. Check.
Binary is
Okay, so this number is not a denominalized number. It's not super small. Anything is not super small cannot be said. It's large.
Oh, this is large.
It's a large number. Okay, so when you log it, what do you get? You 254. Okay, you already got the answer. This part. So from here, right, how do you calculate the matrix? You need to times what? 254 minus
this one will be
126. 127. Right? Oh. This part I think this part actually is the normal way.
So I don't understand the number.
Yeah. Okay, you don't have this zero actually because it's only 23. So this one just put like that. That's all. It is 23.
I forgot.
I know, I use this format.
So it's actually 254 minus 127. So you get 126.
So I then up there it was like
So when you multiply, you should get 1 point something or 0 0.9 something.
exponent.
So you minus 1 and 0 0.1.
Yeah.
Yeah. Then you should get the answer.
Then because
Is it easy or hard?
so that's why the next
Very fun, no?
For 1.7 times 10 to the power of negative 39.
Because that one is convert to
Oh yeah, so if this is negative 32,
This is negative.
Are you giving us a picture for it?
that means this negative 39 of 1.7 is normal.
This question I already cannot.
Normal is times 126. Right? That's right. So 126. And then what's the bracket as high?
It's plus.
Oh, 3.
Okay, so this one I still think it's
Wear
negative.
shorts to school.
Oh.
I feel weird. 121 something. 121. Oh, you.
I just put this here.
Oh, okay.
Can is can.
4, 8,
Because I don't need
20.
Oh, okay. Then
Microprocessors.
get it.
Have fun.
It'll make it a full.
Yeah.
More weirder than explaining. Oh, my life is it. No, shucks.
Okay.
What for
No,
them?
this is-
We will not talk about
Let's see.
And this one.
Is it?
Full number.
Wait, I have a question.
Yes.
If it's a normalized number, why should you identify the sign and exponential?
Right, because this one.
Sign, yes.
Yeah.
Exponential is all 0. What?
Not the one.
Yeah, it's denormalized number.
Then the thing like that.
My mental stuff is
Like that.
my mental stuff is very, very wrong.
Oh, hey, then like that. Sign is also 0 because it's not
Yes, it's a
minus.
positive number. Very good.
Yeah.
How's your
So that means
zero?
number 3 is whatever I
Oh, it's
got.
45.
Yeah, because of because this is what number is denormalized. Yeah, all the ones at the bottom is not yet.
Very fun, right?
The edge at the edge denormalized.
I thought, okay, wait, I thought the number was like 8 super negative 50. Never mind.
You check, you can check. You can easily check. I give you the bounce rate.
I can't read numbers. Like 2, negative 1, 4, 9. Oh yeah, you're right. Hold on.
It is
Let me just
within the song.
Yeah.
Just within.
Yeah, very good. I give you the bounce rate.
Actually, that one.
It's not given, this one.
The sun is not brain cells, but I don't have a brain cell.
Go and buy all.
Wait, for the fourth one, I don't need to denormalize it.
No,
It's
it's fine.
just within the bounds.
The
1.8 if you can
you still need to be normal.
But dude, it's in the bounds.
Wait,
It's in the bounds. Why do I need to denormalize this
1.8
shit?
is out of bounds. Wait, is it out
The
of
1.8 one, right?
Yeah.
Because it's within the denormalized range. So
Wait,
it's within
wait,
the
keep
denormalized
it.
range. Like it's within there. Yeah. and that's 1.8. So it's like
It's
just
like-
after.
Yeah, it's after denormalized.
The denormalized range is
This
the,
one.
the end
this
is
one,
yeah,
I'm
the
holding
end
it.
is there. So your 1.8
Okay,
is
calm
like
down,
that's the
sis.
left. This is the right. Imagine that's the left point. So it's a bit
It's like a slider base.
yeah. And think of it as a slider base. It's right like
Oh,
just after that point. Yeah.
So it's like if it's 1.3, then it's already
Out of it. Yeah.
Hmm?
Yeah.
Is that how it works?
I don't know. Bro.
Because
I
this
thought
is
I
not
knew how
negative
math
positive.
works.
It's just the
Oh yeah, it's just a piece of
Yeah.
This is why I got no more friends already.
I
Yeah,
don't know,
excuse you.
bro. I thought I was good at math before this.
I'm around all the time.
1.8 into 10 raised to the negative 45.
So lucky this is not your exam paper, right?
I don't know.
Anyway,
This
I
one-
will try during exam.
I already got PTSD from electromagnetic.
No, actually final question one.
Can you help? Can you help her?
Wait,
You got the answer already, I can help her.
So this is 2 raised to power of negative 126. This is 2 raised to power of 1.
Identify
This number.
Is so this after
It's
this
very close here. I know that.
no actually this one is closer to the
Other
to
side.
negative 149. Yeah, it's very close to
So
there, but
I mean,
it hasn't
oh,
went over yet.
Wait,
It's like legit at the end.
tell me, you skip
If I
exponential
say
this whole
this
time?
is negative 149. Let me just
She only just need to calculate Mantissa.
No,
Oh,
I don't even know what
understand.
you do step by step right now.
Okay.
Yeah, B text
Oh.
Yeah, she
Yeah.
skip exponential. She skip
Is
It's like
it?
still within.
See, I don't know.
It's still wrong.
What?
But if it's 1.8,
Okay, so
then should it fall somewhere here?
God.
No, because that one won't work if the number is negative. But this is not negative. This is the
Positive number.
it's still a positive
No,
number, but
still
it's
wrong.
only the 0.0000
Why? Wait, why
the
is-
decimal the
is it
decimal
cause you
values.
look at-
Oh!
Yeah, but if you think
She
of it
never
as
add
like
the
that,
She kept having
this value.
007
Then we
She
can't
never put the two F's.
This value.
That's why she kept going
This is
007.
like-
She only do.
okay, let's say you think about it. This is negative 1.8.
I got 33
Then yes,
bits.
negative 1.8.
Oh, wait, this
Don't know how you get
Right.
23 bits.
Yeah, but I
No,
think
no, no, it's
the
not, it's
first
not.
9 bits.
This is not.
We
This is
decided
only
that's
if
what I
you
told.
look at the value.
Ah, okay.
What a
So
joke.
if you take out this thing, it's actually you treat it as a normal number.
Alright,
This would be
question 3.
if you don't look at this, if you just this
Oh,
thing
it's
is
smaller than
confusing you.
this.
Yeah,
Okay,
this
that's
this
right.
thing is still confusing you.
Ah, I
That's why.
see. Yeah, bro.
This one?
But if it's negative, then
Question
it makes
So
sense.
exponent won't
Zero,
be
zero,
affected
one,
even
two,
if I need to
eight.
normalize it. But when this
Uh,
is
I'll check for you. There is some number one. So you most likely you should be right.
I told her I really don't mind being wrong. My life is a joke.
Or you check check them. The both of them do
Remember,
already.
you just like, I was also confused and I look at this guy like, oh, normalize.
What's your number?
Don't pick up my pen.
I just said what we call my every time. What is the question 3 answer, which is 0012828?
Normalized. So if it's denormalized, then
Wait, which one? That
Question 3.
the 1.8 or the 1.7?
Oh,
Why
sorry.
is it so aggressive?
I agree. I'm a joke. Yes. I feel like it's wrong.
Which one? The 1.8 times 10 to the power negative 5.
Yes, it's big.
Negative 5.
Negative 39.
Oh, that one? That one I got
001.
128E9.
oh,
00128E9.
0128. Huh? Wait,
Let's
00128E9.
Ah.
Mine is 0012828. Hey, sorry. 128. 128.2E8.
What was your decimal?
I thought, wait, was I supposed to up the decimal thing when I was doing visa or not? I know exponential, you're supposed to just roll it. I just write the number there.
How's your exponent?
12131. Oh, mine's 1213161. Because it was 0.7 or 6 or 5.
Question, weren't we supposed to just forsake it?
You're supposed to round it. I mean, he said round it lah, so I just round up with this.
Can round. Mantissa can round.
But for exponent is
Exponent cannot.
Cannot, must be floor. Yeah, that one must be floor.
That's not.
Dude, how's your
Give me the
exponent zero?
argument for that.
How's your exponent 0? Here.
Because it's denormalized. So if you look at this, denormalized exponent is 0.
Okay. I feel very down now.
It's just a lot of stuff. This thing helps.
I'm lost again.
Huh? Oh, okay. Then now suddenly a random one.
Yes, Mantissa is one. Got that.
Wait, so if it's denormalized,
Let's
right,
do the
then
last
your Mantissa is something totally different now.
Yeah, Mantissa will be. He had that thing just now. I think I wrote it down. Wait, I wrote it.
Last
never mind.
number,
It's-
3.2.
You just take the number, you times 2 the power to 6.
It's to 1 to 6.
You
So you don't
offset
care.
everything, yeah.
You don't care about this, basically.
Yeah. Because the exponent is by default 0.
Right. Oh, okay, okay.
Mm.
Right, it's minus
Mm.
0. Eh? No, it's not.
No, like the just look at the you normalize from x1 is 0. Yeah.
Yeah.
So that's why whatever you did for this, you just
Okay, I see. So it's just 1 to 6. And I also times 20. Right. That one is to make it normal.
Oh, this is out
What?
of range.
It's the same as this. isn't it?
I found the
yeah,
other
the back
Oh,
price.
so the only difference is
Yeah.
this. Oh my god. Okay.
Infinity. The last one is infinity.
Yeah, I got infinity.
Infinity.
The last
and
one?
Beyond.
The last one.
I mean, just now I was asking you why you said can be infinity.
Is it not infinity?
I thought it was not a number. Then after that she said it's 0. Then I'm like,
No,
huh?
it should be 0.
What?
The best answer is 0.
Something's not right.
1.4 is here. Negative 3.22. Hey, wait, it's in the range though, right?
Sorry, which
The
one?
last one is in the range.
Nope.
It's out.
Oh,
Watch me fail the first question in the microbeat final round. Captures and burns.
Actually, I should write with a different.
Okay,
I just highlight lah.
I'll just wait for
Last one I don't
explanation.
get it.
Why is the fourth number weird?
I got why the fourth one, because
Fourth is a trick question.
the fourth is meant to ruffle you.
Yeah.
What?
It's normal? I'm not doing normal.
Oh, the number very nice, right?
Yeah, what the hell? All the way
Why
at the
makes me
end.
cry when that's the thing.
Very nice, right? Well, even usually exam give you this one, you look at it, bro.
When I freaking predicted the exam question, eh?
Yeah, if really exam come out, right? Oh, let's all go eat Hai Di Lao. Okay, so this is the answer.
How is it?
Yeah.
It's just 0, it's too small, right?
Wait a minute.
Is this a paper?
Wait.
It's just too small. This is my.
Your PhD paper.
My semicolon Monday.
Wait, what?
Oh, I should have studied with you on semicon.
That makes dumb sense. The number I get is 1.2845223. I mean for question 4. Then when you change to binary, then hexadecimal, that would make sense.
Oh, okay.
Okay, yeah, that actually would make everyone paranoid. that would make everyone paranoid.
If this question shows up, I'm feeling my finals. So it's just like
No, if this question come out, you know the answer. The freaking answer is here. And this is only like 6 marks only. Or how many marks is this? This is
wait. No,
this is
that's
only
like
6
four-
marks. Yeah, 6 marks for 2. It's very little.
Oh, actually.
Oh, it's 4
No,
marks.
it's 6 marks. 6 marks.
It's 4 marks.
Yeah, 6 marks.
6 marks is the
Wait,
second
wait,
part.
are we looking at the same?
No,
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 no, but
no,
C,
no,
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 but
Part C
C.
is
Oh, 4 marks. Okay. Oh, sorry.
We spent 1 hour on form.
Okay, but because this one is supposed to do it very quickly. So by right, you need to practice so that you can do it quickly. Because this one shouldn't take too long of your time.
Trying to cycle past your papers tomorrow.
I'm gonna do that on Monday.
Okay, so at this point, right, this one should take you less than like 5 minutes. Or less than 2 minutes.
Okay,
Because it's 4
just-
marks, 4 marks.
Just one last question.
Ah, possible.
We should aside. Suppose after we get the sign,
Yes.
the Mantissa, and the
Exponent.
yes, that thing.
Uh-huh.
We get all 3 right. Then we individually first of all convert sign to sign. We individually convert the Mantissa to hexadecimal, right?
Wait, I thought
Exponent to hex, is it? Then we
Yes. Yeah, you can do that also. For me, what I do is I just write all decimal, all binary.
you write the entire
Binary, then after that I just do hexo for everything.
you write like
Yeah.
But you can do either way. And anyway, it's comfortable as long as it's correct.
you write sign, exponent, Mantissa, like in the particular format.
Yes.
given In binary, then you
Yep.
extract it to hex.
Yes.
And that's the number.
Yes.
Got it.
Yeah.
Thank
You can do you can do 2 hex and then combine because usually it's faster that way. Yeah. But make sure you
Your partitions
you
are
take care of the boundaries between the mantissa and the exponent, as well as the sign, of course. But the sign should be easier. The mantissa and the boundary, that one just careful. Yeah.
So I can technically like compute the hex for each separately.
Yes,
and
yes, yes.
combine
Then you
them.
can combine. Yes, you can do that. Yeah. You just
So
have,
I don't need to care about the boundary in that case. I will just.
but you cannot just combine like that. You must combine with the understanding of the binary numbers in between. So like imagine there's 7 and then the other one is like maybe it's 1. So the 1 and 7 become F.
Yeah.
Yeah. So you just have to
Melt like the boundaries.
yeah, you just have to know that can already. Then it shouldn't be a problem for you.
Okay. Thank you, Anwar. I now know how to do IEEE.
754. This is only single floating point. There's double floating point also.
Double precision.
Yeah, but I don't think it's tested, right? Is it tested?
I don't think it's
I don't care.
me.
Let's just put it that way. I do not care anymore.
We can get half marks out of the whole.
If it's tested, then it should be double the rate, double.
Yeah,
Every
like it
double.
goes from 38 to 308 or something.
Yeah, yeah.
Yeah,
It's even bigger.
it's a giant. Why the fuck is it a giant?
If they want to put 4 marks, I don't think they will test.
Wait,
Imagine 10
So
marks.
big.
who's doing the paper? Sorry, I meant who's
Setting them.
there we go, setting the paper.
Is it the gun?
Is it the one that's
Gun won't
the one
send.
that's like retiring?
No, I don't think so.
Oh, phew.
Okay, so Veronica, you want to write down the thing, then we go on first. You can, yeah.
Still don't understand the last one. What is it? Zero?
Yeah, can you explain? the
It's just
last
too
one?
small. If you have a number that's too big, then you just say it's infinity.
Then they just
Ah,
number
so too small cannot call infinity lah.
Yeah, it's too small, ma. How can it be infinity? It's either not a number or 0.
What the
I mean, just now I said, but yeah, but actually it's not a number.
It could have been just called negative infinity.
A bit difficult to say not a number also, but yeah,
What's
but I
your-
think best is just to say 0 lah. That's the best.
What's the distinction between any and 0?
The exponent has all ones, ma, which I remember.
Okay.
So in this case, the exponent is
This is all 0. Everything is 0.
Everything is
all
zero.
Everything is 0.
According to the condition. I'm sorry, I took it.
okay. Okay.
Oh yeah.
Okay.
I was actually good.
Sometimes during the exam paper, if I'm not wrong, they give you the hex value, then ask you to calculate what's the number. Yeah. So I hope that should be easier lah, because
Actually, I should just bring out the example.
164. For that
okay,
side.
so you write down already?
Yeah,
Yes.
Okay, then let's head on, right?
Yes, sir. Yes, sir. Let's go find out the other cost points.
Okay, so this one is 11 marks. So this is the one that is more lucrative, right? This is only question 1, by the way.
Yes, we realized that when I thank you.
Okay.
We knew it was question one.
Let me
So-
double check everything.
I'm just going to find a printing shop. But
Yeah, actually the rest is not too much of a problem lah. Yeah. Okay, done. That's just kidding. Okay, come. Okay, so figure 1 shows an ARM assembly program. Right, answer the following questions after running the program and the stop label is reached. Okay, so this program by right shouldn't have any issue lah, because they didn't ask you to find any problems in the program, right? So now we need to go step by step. So actually this is more of a practice issue and more of like, rather than anything that you need to memorize, you just need to know how to, compute together. Okay, let's start. Show the values of register R4, 5, 6, 7, 8, 9, 10 in hexadecimals. So everything must basically you run everything first, right? Correct? Okay, so now R4 is what? Can anyone tell me? R4 is equals to?
The address minus 4096.
okay.
Yes.
0, 0, 0, 1.
So it's 0x. 0x what?
4, 0, 0, 0, 1, 0, 0.
So 4000, 2000, right?
Oh, there's a base mode. Figure out how to do hexen.
Yeah, you see that, right?
Hex.
Yeah.
Dot hex.
Very good.
40.
Yeah, 4096 is just, yeah.
No, because you need to change the decimal minus 4096, convert that hexagon, 2000 become 1000.
Because this is in base 10.
Oh, 409. Ah, so you need to convert base.
Oh, wrong already. First question wrong already.
Now I'm busy staring at that. I just went down to CC. Then I'm thinking, I'm spending 1 hour doing question C. Now, do we go to the
Decimal.
No, the reason why I took longer because I want to make sure y'all can do it quickly. Yeah, that's the most important because y'all still don't know. I asked y'all question, don't know.
It's 1000.
Yeah.
Yeah.
400,
4,000, 1,000.
So the 1,000 gets deducted from the 2,000 at the back, right? Because the base address is 400,200.
You convert the address to decimal minus, then convert back to hex.
I just converted that to hex, and then I was like,
Wait,
the
wait,
answer.
Both
think-
works.
I keyed wrongly.
Yeah,
Yeah, I keyed wrongly. I keyed 1000.
that's why
Minus
it became,
four.
yeah, that's it. Okay, R7 is a fun one. Left shift to
Okay.
Anyway, just to clarify, when you left shift by 1,
Yes,
multiply
yes.
by 2.
Ah.
Left shift by 2, multiply by 4, right? By that logic.
Oh, you mean this one?
Yeah.
This multiply by 4. Ah.
Yes, thank you. R5 plus R6.
And anyone got the program can run this or not?
I have keel on my thing.
Hey, can you run this program? I wrote already, but my program cannot run.
Oh, okay.
I don't know what's the issue.
I mean, it says it will show the value of the flag.
But you won't get to run the program during the final, right?
No.
Why we are running a program? Because we want to make sure our answer is correct,
I
right?
don't want to care for the program. That's the thing.
uh,
I'm lazy.
unless you can help me debug my issue, I don't know what's the issue. This one fail to execute. I think it's just a
Did you build it?
I cannot build even. Can't even build.
I think it says show the values of the flag. Is there like an issue in there somewhere?
It's like NZCV. So adds S should
Yeah,
like
I
lead
think
to a
my
flag.
computer got
That's the
problem.
thing.
Yeah.
Camera phone.
Yes.
Like when that thing is triggered, there should be a flag notification that comes.
Really only
Or 5.
New project.
Wait, LSL of 2 is mean shift the thing by 2 to the left, is it?
What?
The one that says add S.
This one, yeah. LSL is it?
Yeah,
Yeah, 2 lah.
2. So 2.
Are you done with this part?
Let me figure something.
I'm still figuring
I
out
want to
this
see
part.
It's an ASM file, right? .s, right? It's .s file, right?
Assembly file, yeah.
Why cannot work?
There.
So angry.
Oh,
I typed the whole thing.
So our code is this.
this one.
Wow, annoying. Cannot.
R4 will
Cannot.
be this. R5 is this. R6 will be this.
R6 is
R7.
Okay, I hope my answer is correct.
R6 is
Okay, what does MBN stand for?
Oh wait, it's MBN, not MOV. Oh shit. MBN means it's the complement of it is getting shifted inwards. So it has to be reversed.
I don't remember what's MBN.
Never.
Okay, so it's actually move, but move the negative part. So so for example, you have 0x 00000 blah blah blah, right? You move the 1 2 3 4 5 6 7 yeah, like that. So right, if I move this into R5, for example, right, you become F 3 4 5 6 7. Then the 1, right, because 0 0 0 1, I do the opposite, become 7. Can see that? So basically, right, I just do a first complement.
Invert.
It's just inversion only. It's just inverting. It's finding the first complement. That's all. So MVN stands for that.
I in the chat, guys.
Okay, so your R5, I mean, is actually equals to. Can anyone tell me?
It's like
0
1,
F,
2, 3,
7
4, 5,
F,
6,
1
7.
7.
7 Fs and 1 7.
Yeah.
1 7. Where did the 7 come
Oh
from?
shit, why is there a 7? Wait, I don't get why the 7.
You invert 7 become 8 lah.
7
zero-
is
0 1 1 1 like that become 1 0 0 0.
cube squared to 1. Wait, hold on. Let me figure this out. 2 cubes.
It's just here. Like that.
Seriously, let's go there. So 7 is 0 1 1 1. Yes.
Okay, R6 should be easy, right?
0x20. Please be 20.
R6 have a question. When it becomes double
What 20?
Whoa!
Huh? R6 eh?
How are you guys so fast?
No, I thought it's after the x, or is it just 0x8?
True.
You guys are too fast already, bro.
I don't know, I'm lost, I'm lost.
1, 2, 3, 4, 5, 6,
8.
7, 6, 8.
Hold up. When you do the left shift left right and you do 2, does that, how do you multiply the 2? I'm somewhere forgotten where I am.
hexadecimal.
Hold up. Wait, I know where I am. Never mind.
Hexadecimal already.
0, 0, 0, 0, 0, 0,
So
0.
0x8. Is that not in hexadecimal?
Am I wrong here? R6 is 8, right?
It's just 8. I don't think
R6 is 8. Oh, I think R7. Never mind. I don't know what's going on, bro.
7 is the complicated.
R7.
Oh, okay, right. The 20 that hexadecimal was because of the LSL2.
Shift bit
Yes.
twice, right? So I
So,
shift
20 plus your thing,
shift here, 0.
which is
0,
F,
0,
F,
0.
F8.
Let me see. I know done. I'm in hex. So let's
How many
say
numbers to combine?
F8 plus
Wait,
0, 0, 0.
did my R7 became overflow?
0, 0.
Alright.
Over, is it?
I got 18 in hexadecimal.
I got 7 at 8.
Huh?
How the
Why,
fuck am I getting that?
Why am I getting 0?
F, 1, 2, 3, 4, 5, 6, 7, 8.
Plus 20 hexadecimal.
Why are you getting 20 from?
You shift R6.
Yeah, so you shift the 8
Yeah.
twice, right? So it becomes 0, 0, 0, 8, 0, 0, 0, something.
Is it?
Like the 8 gets shifted this way twice. So
I shifted it twice in binary format. Is that kind of wrong?
I think that's right.
1, 2, 3, 4,
Well,
5,
it's like,
6, 7.
yeah, sorry.
I'm just trying to see whether I can run something.
Man is a bit busy, guys.
Cannot.
Okay, you know what?
Very not
Screw it. I'm gonna do the hard way. 0, 0, 0, 0.
Okay, come. So for the ads, right? We do this one first, correct or not? So when we do this one first, what is the answer?
20.
So 20 is it? Okay, so you shift 8, right? 2 times. So you should get 0x 0, 0, 3, 4, 5, 6. Right? 7, where you so the last one is 0, right? So when you move twice, right? 1, 2. So that one should be 2 ma? 2, 0. Agree, right?
Agree.
Okay, I guess I can do a binary setting.
I do the binary way lah.
Yeah.
Okay, so what does adds actually mean? What does adds actually mean? Adds what? Adds into where? Into which one? So in the R7, right? You add R5 and R6 plus this one, right? What is the value of R5?
0,
Okay, so when we add them together, what happens?
0, 1, 8. That's what happens.
What overflow? No, not overflow.
Oh, that's what the S was for. I forgot what the S.
Hello, yes. So what happens? When you what does R7 equals to?
0x 1, 8.
Are we supposed to ignore?
Wait, is S for the overflow?
If you remember when you do subtract, then only when you come back. That's
Okay. What is the negative number? What does this represent? What is this? What does this represent? What's the value? Value is
I need to like.
What language you want me to answer?
okay. This is a negative number, right? Okay. So can we calculate the binary value or the negative value? So it's negative what? Negative 8. This is decimal, right?
Yes.
Okay. So let's double check whether is it correct. So blah 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 blah. So we minus 1 first. Minus 1 become F, then become 8 is 1 0 0 0, right? Become 7, right? 0 1 1 1, right? Then we minus 1 already. Then we invert everything, right? So invert everything become 8 lor, correct? So it's the minus 8 lor. Yeah, you're right. Okay, so minus 8, and then this 20 is actually right 16, right? This base 10. So R7 is actually right 8 base 10, which is actually equals to 0x 0 0 0 0 0 0 0, 8 is just 8. Yes, yeah. Because it's in hex, yeah. Like that. Okay, clear enough?
Yes, sir.
Oh, I think I got wrong here. I got 1 8. How did I get 1 8? I think it's 8. I think it's 8.
Oh, wait, I think this one's working.
Okay, you typed in already.
No, you should.
Sorry.
Alright.
Oh, you typed in already, right? So what's the value? 1 8, is it?
Yeah.
Oh yeah. So my answer was correct. So how do you get 1 8? This is 16, right? 2 what 6 2 6 1 1, yeah. 2 2 2. Oh, sorry, 32.
You are supposed to multiply
32.
8 by 4. That's what I
32.
was wondering.
Then
Why this is not
32
making sense.
minus 8 is 24. So it's 24 in base 10. So 24 here should be 1 8 because 24 is 16 plus 8. Yes. Okay, I just made a careless mistake only. Yeah. Apparently I mentioned. Yes.
I'm lost from the start.
Okay.
I think from the outside I lost it.
Okay, so until this part you understand, right? From this part onwards,
Yeah, that one I
okay. So add basically, so for add, right, you just add the binary, you don't care whether is it negative or positive number. So you don't care whether it's a two complements number, right? You don't care. But since it is actually a two complements number, right? So what is a two complement number? Your two complement number is actually 5, R5, because you actually have this value, right? Your MSB is actually 1. So when you add R5 and R6 together, you agree that R6 is actually, right, 0x20, right? This one don't know. Okay, so R6, right? What is R6? R6 is actually this. They don't agree, right? Okay, LSL, left shift left. So what happens is we have this one, right? It's actually I just write 0 0 0 0 1 0 0 0. This is actually 0. This is actually 8. Agree, right? We left shift 2, right? We shift this bit left because not everything is 0, is the same, so we don't care. So actually end up become 0 0 1 0 0 0 0 0. So this is actually 0. This is actually 2. Can see that? This is how we get 2 0. So this is just the left shift left only. Okay, so from the left shift, right, we get this, right? Yeah, we get this, right? Okay, so from this number, okay, we add this negative number, right? So some actually you can do it in binary, you can do it in hex, but I will do it in decimal because it's very intuitive to see, right? Negative number and positive number, you just add, then you can get the correct number. So for me, I'll do it in decimal. So what do I do is I actually, right, just identify what is the equivalent negative number of this R5, which I get -8. Which you can actually do by doing the two complement, which actually Spencer just do a shortcut. I think he got it already. So we got a -8. So what is this value? This value is actually 2 times 16, because this is just 16 to the power -1. This is 16 to the power 0, this is 16 to the power -1. Sorry, just 16 to the power 1, 16 to the power 2, 16 to the power 3, for example. So this is 2 times 16 to the power 2. 2 times 16 to the power 1. Okay, which we get 32. And 32 minus 8, we get 24 in base 10. And to convert back into hex, we get, right, 0x18. So for R7, because we store inside R7, our value is just 18. Okay, so now we see sub. Sub is just subtracting only, right? Correct. But this one don't have the S, correct or not? So there's no S, right? So if there's no S and then there's overflow and what, right? Then you send a signal, right? You up the flag, right? Okay, let's look at this first. Okay, so for R8, what do we get? Right? So we need to subtract R6 and R5, right? So what minus what? R6 minus R5 or R5 minus R6?
R6 minus R5.
Okay, very good. R6 minus R5. Okay, so what do we actually get?
Don't you just get minus like just one.
No, I got 10.
Oh wait, oh yeah, it's complemented.
like that.
Yeah.
So what happens if you minus it?
I got 10. We cancel that thing. And it
Makes
means
sense.
mana overflow.
No, makes sense.
Oh yeah, I got 10 as well.
Yeah, yeah, right.
Supposed to be 10.
So is there a flag that come out?
No.
Don't have? So R8 is actually equals to this. That's all.
But if there's a flag, right, then will answer be the same.
No, the answer is definitely the same one. It's just whether it activates the flag. The flag doesn't affect the result. The flag is just activation. Yeah, if it passes a certain checkpoint, for example, whatever checkpoint it is, whether the answer becomes 0 or answer becomes negative or overflow or whatever, then that's a checkpoint where it activates the flag. Yeah, the flag doesn't affect the result.
Now we need to do R9.
So store R5. What is this bracket thing? What does this mean? Anyone knows?
Both are 3.
Okay.
Doesn't R4 point to the address?
Yes, exactly. So the bracket actually means, right, whichever address that R4 points to. So what do we know? So for R4, right, R4, the value or the address of R4 is actually 4000, 1000, which is actually calculated earlier. So this is our R4. And this is our address. So we store R5 into this address.
Oh,
Makes sense, right? Store R5. Yeah, store R5 into that address, correct, right?
R5 is to address the R4,
Yes. Into address that is stated by R4.
which explains why question the third one says what is the.
Yes.
Oh, okay, I need to pick up.
Okay, so what is LDRSB?
Load time byte.
Sign byte. Okay. Okay, so maybe we look at our library, okay, our thing. So in our memory, okay, we got 0x 4000, 1000, okay? Okay, again got 1002, 1004, 1006, 1008, okay? Let's see. Wait, I think
R4. This one is 3 indexing.
So value from. Okay. So wait.
Doesn't that mean when you're loading the value, you load it from 2 offset of the original address for the LDRSB?
wait, I think I should write like that. 0001. Like that, right?
R5 is 7x1.
So this one, what do we store first? We store what?
R5.
R5, right? What is what is the first what's the number that we put inside? Into the 00, this part. Yeah, so what do we put inside?
7.
Sorry?
7.
Why 7?
What's 7 for FF?
Wait, I got it wrong already.
Isn't it like gonna be FFFFFF?
This is your R5, right?
Yeah, don't you need to store that?
So what do we store inside?
At address 04 character 100, we
Mhm.
store 0FFF8. But then it's gonna be 2, 2, 2, 2. So it needs to be split 2 by 2, right?
So wouldn't 00 be 8F?
So okay, so in the memory, I don't put like that. So from the memories, this is starting, right? Okay, starting, right? What is the first two binary the first 2 hex value that we put inside? Very, very important. What is the first 2 value we put inside? We know we put R5, right? Correct. So what is the number that we put inside? Inside these two two first slots. You say FF. Okay, what the rest of yours say?
Yeah, wrong.
You say 8F. Okay, what do you say? Oh, I think got 3 different answers already. FF, 8F, and F8. Okay, anyone else?
I'm lost.
Oh, you only got few choices only, right? It's only here. Okay, here. Right, very important. Which one do you put inside? Okay, you say 8F. Okay.
I don't know what's going on anymore.
Okay, so what do you think the answer? That's why I need to ask y'all, because if I tell you the answer, y'all be like, oh yeah, makes sense. Yeah, but then you'll never go through. So you say 8F. So everybody agrees it's 8F.
Sure, why not?
Okay, the answer is F8.
Why is it FB?
So I'm right, yeah.
Answer is F8 because you take the least significant one.
So you go like
You got alien, right?
Wait, I thought this significant is all the way to the left.
Yeah, but it's not tombalik. The number doesn't flip. Okay, so for example, if I took 1, 2, 3, 4, 5, 6, 7, 8, for example, right? These are the least significant one, right? So we put 7, 8, then we put 5, 6, 4, 3, 1, 2, like this.
Yes,
Understand or not?
Got it. So basically just
It doesn't you don't flip. It's not mirror image. You just take the chunks only. Yes, just extracting the chunks.
Hey, your 4 3 to balik lah.
Oh.
3, 4.
Yeah.
Eh.
I'm confused.
I don't know why I write 4, 3. Sorry. I keep talking about not mixing it up, but I mix it up. Okay, sure. So this one understand, right?
Yes.
This is inside the memory. So inside the memory, right, as you recall, there's always like 2 boxes, right? Okay. So if I write F, and F8, correct? This F8 will go this one will go this one, and it doesn't change, there's no like.
So it starts from like the least part.
Yes.
And it leads to the most part.
Yes. It starts from the least.
Yeah, this is how I remember it. I just
Okay, think of it this way.
I don't know, bro. My memory is gone.
So the address here is 40001000. The starting address. So what's the second address? What's the yeah, okay, can wait, one address represents 4 bytes.
Yeah.
Correct?
Wait, so won't there be like a 00 buffer?
What's 00 buffer?
I don't know, bro.
I always forget.
Then what is this address then? What's this address? What is this
Wait,
address?
that's gonna be 100, 1001, 1002, 1003. But when you're filling in the values.
So this should be 1, right?
Yeah.
2, 3, right?
Yes.
Okay, I never remember wrongly, right?
No, you're correct.
The
I'm
2
sorry,
numbers is
sir.
4 bytes, right? Correct.
Yes. They're 4 bytes.
Oh, wait, 32,
Yeah,
32.
they're 4 bytes. 1 byte is 8 bits.
So F, this one is what? This is 8,
1,
right?
Yeah, this is 1. So
This is 1, 2, 3, 4, right?
yeah, then you have another F, so it becomes 8 up.
8.
8.
So this is how many? 1.
There's 2 bytes, right? No, wait, that's 1 byte.
Yeah, confused. Are we shifting things again?
No.
This 1 byte.
Yeah. The bytes are byting. FB, FF, FF,
Okay, so below is 8 bytes. Then
no more
there
S.
is 2 BYTs plus 1
What do you mean by 1 2
BYT.
3?
No, that's the other address row.
1001, 1002, 1003.
But
if you see the computer here, then you can see.
I forgot already.
Okay, you know what? Let's just carry on.
Oh, this is important though for the next part. So do you remember? Anyone remembers
No.
What?
No,
the address?
Veronica is running it right. You can ask her. I'll bring my phone.
So if you look at it, then you can
isn't it? Oh, okay.
Oh, yeah, this is correct. This is correct.
This is 3. That's how I remember it.
Oh,
Okay, let me shift it.
Okay, just remember that every 2 boxes, right, the memory increases by 1. That's all. Yeah. So for here, right, this one is actually just 4000 1001. 4000 1002. 4,000, 1003. Okay? Okay, let's go.
So is
Yes.
R9
So what's R9?
is R9 0x FFFFF?
Why are you so fast?
R9 will just be getting the value from the four.
Okay, so like that, this one is actually, right, 0x4000, right? What else? 1002, correct? Okay, 1002. So it means that we are actually taking FF. So R9 equals to F 0x123, like that. Because you take that one, right, you automatically fill the whole thing. Correct or not, Veronica? The answer is correct, right?
What?
R9, R9, R9.
How do I see on my way?
Correct, right? It's all 8F, right?
I'm gonna go P.
Because if your MSB of the value that you're taking is 1, you fill the rest up to the full MSB to become 1. I remember something like that. I remember that was the rule. If you're taking something like 7F, then your answer is just 0x7F, for example. Because the MSB, right, is 0. So everything we fill is 0.
Wait, you said 0x, is it? What?
No, if you're, for example, if you're taking from the memory, right, which is 7F, for example, right, then the result of R9 will be just 7F. But because the correct, right, is correct, right? Okay, very good. So that is correct, because because this is the answer, right? This is from your memory, but it fills up the rest with 1 because the leading edge of the leading MSB of this value that you got is actually 1. So you fill out the rest, and that's the reason is because if it's a negative number, then you need to preserve the negative number, and if it's a positive number, you preserve the positive number, so it becomes 0 all the way or 1 all the way. If it's a negative number, the leading is 1 ma, so you need to make sure that the leading is 1 also, so you 1 all the way.
So you're saying that for the 40001002, the only thing that is being read is FF. However, the rest is FF is 1, the rest is 1.
Yes, you're right. Yeah, 1002, you only from the address, you only get FF from this address. Okay, you only get FF. Okay?
Yeah, why is the rest also FF?
Because you need to preserve the positive and negative value of the number. So if the leading is 1, you fill everything up with 1. If the leading is 0, the MSB is 0, then you just fill everything up with 0. So if you do the 2's complement, right, you are able to get a correct negative value or positive value. Okay, what is this? Store. This one is byte. Okay. Byte R8. So we store R4. So we store R8, right? Okay, into what? R4 and this one, right? This is post, right? So do we
Isn't that pre-indexing with write back? It's pre with write back.
okay, pre-indexing, is it?
Pre-indexing with write back.
Yeah, right now exclamation mark, so it's creating.
Okay, so we put into R4 this one, or the post is just like that and then comma, right?
Yeah.
Okay, so R4 #2 exclamation mark, right? Okay, exclamation mark is basically you write into R4, right? You update R4.
Yeah, update R4. Yeah.
Okay, for this one, so do we write into this address or do we write into this address? Which one? 1 or 2?
2, right?
Yes, because it's the same. Same as the previous one. Why would it be different? Understand, right? Okay, so we write R8, the byte. Okay, so what is R8? Just now we calculated, right? R8 was this one, right? Okay, it was just 10. So we just update we update this address. So this one was FF originally, right? We will delete it and then become 10. Can see that?
Yeah.
Okay. Oops.
Wait.
Tumbalik.
Yes.
Okay. Can right? You got this part.
Oh. It's. Give me a
Oh, my charger is not charging.
Yeah, when I go through, it's actually seem very easy, right?
No.
No man.
Not really.
No ah.
Absorbing.
Okay. I means you all haven't had any practice yet.
No, I've had practice, but it's been 2 weeks since I've spoken.
Okay. So for you it was easier lah.
Like for me, the CAs were fine.
Okay.
Now look at this. This looks like alien language.
Okay, so we update already, we cleared it already. So now we go to the last part. What does LDRSH stands for?
Low time
Half
Something
word.
upward
Yeah.
would mean you only take two
So-
addresses.
So this one we only take 2 address, right? This one we take 4, right? Correct or not?
Yeah.
Okay, so this one we only take 2 boxes. This one we take 4 boxes. Okay, so it's basically half of a 32-bit word. Okay. So R4 is updated to 0x40001002. R10 we load into R10. Okay, so we basically R10 is actually has 2 addresses, correct or not? So it's actually 40001002 over here. Okay, I draw nicer a bit. Okay, like that. Okay, then this one over here has 4000. What's the address here? 100. Yeah. Okay, 3. Yeah. Okay, very good. Okay, so this is 1002, and then this is 1003. Okay, 1002 is the lesser, right? Not the significant one. So what is 1002? 1002 is 10, right? Okay, so 1002 is 10. What's the other one? FF. Okay, so what is our R10 equals to?
0x
0x.
f. Then at the end, you need to put that. Yeah.
Okay, this is the least significant one, and this is the most significant. And why do we have F all the way? Because
Pardon?
what?
Because why not? I don't know.
Activity or something.
Yeah, because of I guess is the word padding? I forgot, right? But yeah, but basically the most significant bit is 1, and because it's 1, we preserve it as a negative number, so we do 1 all the way. Okay, yeah, and then that's it. That's it.
Question.
Yes.
So what's the point of the FF? The 1003. Even though like I know the half word thing now, but then
Oh, this one.
yeah.
Oh, this one is they ask us to take half word ma. So half word is actually 4 boxes. Okay, so from this address we took right 10. Okay, 10. You see 10. From the second box, right? Second pair of boxes, 40001003. Right, the answer is actually this one. Okay, so just this one. So we have right FF right 10. Right, FF 10. Can see, right? Yeah, then this is our R10 real.
Oh, okay.
So what are the flags that came out, Veronica?
What flag?
The flags.
NZ.
Okay, wait. Before we go, what are the flags?
NZCD.
N
DCD.
D
ZZZ. VVV.
V. Okay.
NZCD.
What does N stands for?
Negative.
Okay. Z stands for. Someone else answer.
Sorry, I will not say.
Okay. C stands for. V stands for.
Overflow.
Okay. Okay, very good. Okay, so I believe only carry would be 1, right?
So N is equal to 0.
So
Wait, so when you put an S at the end of adds in this program,
Hmm.
it basically asks it to check flags as it's going, is it?
Everything will check. Actually, you need to check. You need to know which one check for flags. Yeah, adds check for flags.
Then what's the point of the S at adds?
This one, the S.
E.
This one, the S.
Yeah.
No, it's so that if you just do an add only, right? It won't. If you only do the add, if you add the negative number, right? It doesn't care.
Okay.
Yeah, it doesn't care whether is it negative or positive number. It just add like it's just binary number only. So you actually go into overflow actually.
So the S is
Yeah.
like
You
still keeps
overflow.
on going. So
Sorry.
S keeps it going. Is it?
S then the flag will be different. Yeah. If you do an adds, right, you realize that your overflow will trigger. Correct or not? You overflow, right?
Yeah.
But if you do an adds, you actually just be a carry only.
Wait, if you do a
ADDS adds.
adds,
Yeah, it will just be a carry only. There will be a carry that's activated.
Can you explain to me what the flags are again? Can't forgot most of it. The NZCV. So N is to determine whether if something is 0 or 1, is it?
If your result is a negative number from a subtraction or from an addition. Okay, your 0 is pretty much self-explanatory lah. If your answer you get 0, like something minus something you get 0, then the 0 flag would like light up. Oh shit. And a carry is if you need to do a carry during the calculation, then the carry will light up. And then last but not least, overflow. So if you add some two numbers, for example, two negative numbers, but you just do a SU, just ADD, just add only, then the overflow will activate.
Which part of this now is the carry?
The ADDS. So I'll just write here, carry, right, become 1. Okay, so I'll just leave it like that first. Y'all can answer question part 3, right? I really
I mean, we already answered
You already know the answer.
Yeah.
I'm trying to think about negative. Wait, negative is the resultant of when something plus something equals to 0. Is it?
No, it's when like your, let's say the MSP of whatever your like, result is 1.
Okay.
Then the negative flag would get triggered.
That I can understand.
Okay, so everyone done already?
So three is from just now that section.
Part 3, yeah, it's just the answer is just here. I already wrote answer for you already, over here. Yeah, I wrote like that.
So how are you supposed to present the answer? The one on top or the one below?
I mean, I was just thinking of listing it and writing what's at each address with the last part.
Oh.
I didn't know there's a seal here.
For each of your resistor values, right? The most. You should not have taken this module.
This module is compulsory one.
No.
Not for me.
Oh, not for you.
Yeah.
Actually, it's not.
Actually, okay lah. I see that once you practice a few times, it's not too difficult. Yeah, exam is when Wednesday, right?
I have an
Thursday,
exam on
Thursday.
Wednesday, then it's
So
on
don't scare us.
Thursday.
No, because I cannot remember everybody's exam. I remember so many people's exam. So I need to keep asking. Every time I keep asking.
We're not obligated to remember everyone's
Yeah.
exams. You need to calm down.
No, there's a reason why, right? Because I need to know when if there's a better time to do things. Okay, for each of the following value, write the most appropriate ARM instruction.
And I convert to
ARM is a code, right?
ARM is the structured state.
Is
ARM is
the-
the state. There's some state, there's ARM state. Right? Or is it a mode?
Thumb.
Thumb is at 16
Thumb
bit. ARM
and
is
arm.
32
Yeah,
bit.
thumb and arm, yeah.
There's states, right?
States.
There's something. I don't
Something,
even know
yeah.
there's something, but there's something.
Okay.
I thought this one was going to be like move, store, load.
Yeah.
Yeah, it's gonna be that. You just need to determine the appropriate.
There's no store
one.
here lah. It's only move or load, right? This
Yeah,
few
this one not
instruction.
Yeah, I don't know how to start this question.
0x4.
Oh my God, what is this?
It's a good thing you can use the
One, two,
question one
three,
as a
four.
reference if you ever forget.
Oh.
There's a store and a load. Just
Oh,
only
one.
put the last two letters of each.
No, but you cannot use store or load what?
You can use move directly.
Sorry,
man.
that's my fault, my bad.
Store and load is not a memory, right? This is
0x4 ROR. ROR by how much? ROR by R is this.
I don't think y'all will be able to get this. This is 12 marks. Wow.
I got the first one.
Oh,
I don't think you got the same answer as me.
Did you get
Oh, it's the same. Very good. I thought it was harder to get, but okay. Then you explain
I
it.
also don't know how.
That's the thing.
How?
No, I was doing like a tutorial question today morning where they needed me to rotate them.
Yes,
And
yes,
that one
yes.
was like 3 million.
Oh.
So
Uh,
similar
Because in
logic.
decimal, you can just choose the hexagon.
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 Hennigan.
I don't know.
Rotate to the right, rotate to the left. FNL.
Wait, but don't need to put the left shift or all this. Just put the number.
Yeah.
Can The number is just rotate, is it? Just
No, you put because you could just put this thing directly. But when you start rotating it, you don't need to write the rotation there. You can just put how much you're rotating it by. That's it.
And then you shift to the left. Rotate by the left, yeah.
You just rotate.
Rotate. So the
don't know how you-
MSB you go to LSB, right?
Yeah.
Correct, right? It's not the other way around. MSB to LSB, right?
No, should not be. If it is the other way around.
No,
it's Wait. Why are you?
It's
why
the other
are
way
you-
around. It's the other way
why are
around.
you confusing
It's
me?
the other way around. It's not negative
Oh my
4, it's
God.
like 4.
Wait,
Yeah.
I just wrote this down.
Trying to figure out how do I
You
write
have
because I don't know how
confused
to do
me.
this.
Who am I?
Wait,
Yeah, it's the other way around.
when I rotate by 4, it's just like gonna go like that.
It's from LSB to MSB. It's like
Yeah, so
clockwise,
if
clockwise.
This number here, rotate to the right. So it's just gonna like go like this.
No, the other way, the other way. LSB to MSB. Yeah. LSB to MSB, and then MSB will go down.
Okay, so this is the number, right? Then I say rotate by right.
As in your answer is correct.
This thing will go here. Right. If I rotate by right.
If you do the comma 4, that one is it?
If I rotate this, yeah, if I do this.
No, it'll be the LSB to the MSB. The other direction. If not, it doesn't make sense because you put 4 only, ma. Then how can it,
You know what? I just explain the rotation.
Sure.
I thought I knew stuff before I started talking.
Clockwise. Yeah. LSB to MSB.
Wait, so when it's rotate to the right, you're rotating it clockwise. When it's rotate to the left.
Actually, yeah, clockwise.
Let me just look it up.
Yeah. It's just clockwise.
R-O-R.
What lecture note is it?
I don't remember that.
Alright, sure.
R-O-R, turn of feet. Fuck that.
Correct, right?
Wait, this one is like, it's recent. It's like thumb to arm. I just saw this a while ago. I had 4 exams back to back. So that's crazy. We just saw this. Where did it go from? What an exception.
I'll just grab my laptop, huh?
Yeah, nice.
So that I can go and run the stupid ARM program.
Yes, yes. Bye-bye. Hi, Matthew. How was it? Can solve or cannot?
I forgot how, but I know
You did something right.
supposed to know how to solve it.
Thank you for returning my calculator. It's fine, bro. I was using the GeoGebra scientific calculator. The online emulator.
Oh,
Oh my god, when it confused me for R. Oh no, I don't remember.
R instruction.
Rotate to the right. Damn it, I just saw it a while back.
I don't get it.
It's just rotate to. How am I not remembering how to do this? Why are you confusing me? Oh, it's much after this. I'm pulling them here. ChatGPT time.
I don't get it.
Can you explain to me?
Looking at his thing.
Well,
I
Hmm.
See what's the difference?
Number 3 is the basic one, I get it.
Yeah.
But
The fourth digit becomes the
the
first.
first, second, and the third one doesn't make
Okay, the
sense.
MVN, that one, the negative something, right? Just now. That one, okay.
No, you need to understand, like, you say this whole ass number,
Yeah, that
All-
one I don't understand.
all he put is just that and that.
Four, one, two,
No,
three.
because MV, and this one is NWN, remember? The whole Tomalik swap.
Ah.
That's why,
It's
because
not
of-
MVN.
it's not, it's different. Look, there's a W in
Oh.
the middle. This is that Tomalik swap he said earlier. Like, you first find what's the number,
Oh.
and then you swap it. The question is what's the 428 for? Is it supposed to be shifting? Because I forgot what's the comma afterwards, because it doesn't state LS, LS, LORS something.
Nothing.
Yes, okay, time is fine. Got that. Understood how it was. Maybe 561. Yeah, thank you for your calculation.
No worries.
I will leave it by your back.
I don't understand.
I kind of remember it. Negative, negative. Now I need to do it for my calculator. Wonderful. This is a beautiful life. Negative 561. I convert to text. Then after I convert to text, this is one. Zero, zero, zero. 5 0, so 2 1. And DCF is DC. E and 11 C is 14 F is 15. And for this, 2 square 0. I hate that. This might be confusion. And then you 2 raised to power 3 plus 2 squared. This is going to be 1. This is going to be 2. So, plus 2. And I need to make a first one. I just started the second part after I remembered our works.
Second part is in, or part 2 is it?
Yeah, second part. Negative 561.
12 marks, 12 marks.
No pressure, bro.
Yeah, no pressure, 12 marks.
Just 12 much, bro. No pressure.
If I'm not wrong, this one every exam paper have, right?
I haven't looked at exam papers yet.
Oh, okay.
It's my first time.
But if I'm not wrong, it should be. So I will try to help you to learn the best way to solve this question, because it's a lot of marks. Because this one, right, is very critical. Like, how to say, you can do it anyway, but the most appropriate one is hard to find usually. It's like you need to have some intuition. So I'll try to help you to understand how to do that. So you see whether I can. See whether I very good.
I got DCF. Now let me invert DCF. D is 1 1 0 1 0 0 1 0 2.
But some is the other way. Some they ask you the other way. I can give you the
No, they ask you to.
C is 1 1 0
the value there.
2 1 3.
yeah.
The last 2 papers, all the hexadecimal. And suddenly this year they decided to change this somewhere.
Yeah, my second answer is not fully right.
I don't know.
You understand the error
Rotate.
repeat by right.
Right. I mean, like you can know how much you can rotate to right. It's supposed to rotate like that. Example is like 2.
You know what you're saying.
Yeah, same.
Why you complicated, guys?
So when right?
Yes.
Let's carry off the ROR, shall we?
Mm.
Convert this to hex. It says, okay, then I want to rotate it by the right. When I say rotate by right, don't I move this entire brick here?
Yes. Yeah. But you see, in this case, this is by left. Like this, I think this is by right, man. Like go.
Oh yeah,
Yeah, you're
I'm
starting
moving-
from here to get to that one. Not this is to go backwards. You know I'm
Wait,
coming.
1 second. Let me write that out. So I'm here, right? So this is this number. I'm here. Then I say rotate by right. Move this guy here.
Yes. That's correct. You're right.
Scare me, bro. Scare me some more. I thought I was gonna fail my TP.
One
I
lah,
still
won't
think
fail
I'm
one
gonna
lah.
fail it, but sure.
Won't fail one lah.
Time to panic.
This one very easy to get A+. No. Not because of that. What is that from?
You're a very interesting person, sir. That's where it's from.
Nonsense.
Yes. 0x.
We're doing this right.
Oh, okay. Very good. Everything can run.
2, 3, 0, 1.
So where are you at now?
The second one. -5,
It's okay if you don't know like if you can't figure out or you don't think that's the best way, you just do first. Later I'll explain again. I'll explain the other thing. So anyway, there will be some time also. If you don't know, then you just try another part.
Yes, sir. Yes, sir. 0x to 3. And Okay, let's look at this. Rotate P by dx. How hard could it
Exactly.
rotate P by dx? Rotate. I want to see rotation answer. Come on, okay, let's go. Rotate by R5. Rotate by index. 32 by 50. Screw that.
Wait, so are you able to
I draw.
where you're at now? Part 3? Part 1?
I gave up on part 1 and part 3.
This time I'm not going to do this.
What's the point of trying?
Because I know I'm wrong and I keep looking hard.
Don't need to study anymore, guys. Stop all that off.
All wrong.
All wrong lah. Jialat, like you just got 1 out of 4. I got all wrong.
I got 1 out of 4. Then I talked to him. Now I don't know how I got the 1 out of 4.
All wrong with before.
Now I'm confused about what I know and what I don't know. That's the thing.
Okay, so Yami, you go through the method to do it first. Then maybe you try another set of questions.
Yes, can
Okay.
please. Thank you.
Okay. Okay, I'll just write the answer first. The answer is actually MOV, right? R1 hash 4 and 4. Just like that.
Yeah, but can you like show me the math part bit behind that?
Sure. Okay. So this one I'll give the answer. Later we the rest we try to figure out the answer.
Yeah.
So this one, when we convert it to hexadecimal, right? So when we convert it to hexadecimal, right, what we get is actually just 4 0 0 0 0 0 0 0. Correct?
Yeah.
Where did the thing come from?
I'm so confused. He hasn't even started yet. It's gonna get worse from here. He plugged that into the calculator in decimal, converted to hex. That's what the man's done. And he's not done anything yet. Hold up. He's not reached that point yet. Okay, calm down.
I just convert only. You have to trust me on this.
Okay, convert, then.
Oh, well, what's the last four?
Okay, wait. So this one, right, is actually what? The 4, right, is actually 0 0 1 0. Right? 0 0 0 0, everything continue, right? This is just the 4 lah. Right? So how do we obtain this, right? So actually, basically, for example, we have many until like that, right? What we can do is we have 0 0 1 0. The beginning, this is actually just value 4, right? This is just 4 what? Eh? Sorry. Sorry. 1 0 0. Like that. Yeah. Then we shift it 4 times. Yeah, how do I?
Wait, what?
But the answer is
Become like that.
Yeah, correct. Answer is
You rotate by 4, right? So
yeah, I get what you mean. Yeah,
I don't know what's going on, bro.
Yeah,
Send help.
let me double check again. Can we find the lecture notes on that as well? Just to confirm.
Repeat numbers to the right. Okay, let me ask ChatGPT. How about that be, bro? Okay, I want to rotate this by 12 bits. Yes. Please use the attributes.
Oh yeah, it's a rotator. Yeah.
It's literally rotating it like it's going like that, as I remember. Okay, please explain. I will listen to you.
Let me double check again. Cause I put so I must put in increments of the increments of must be even number lah basically, right? If I just not put, so I put 2, so I'm testing on my system first, so I just double check my understanding. Just double check my understanding.
Yes, sir.
It
My
become
understanding
1.
is spirit. I don't know what I know and what I don't know anymore.
Oh, so that means I can just put this lah. Actually, I think there could be a better answer. Let me get the answer. 1, then this one change to just 2. Wait
4 bits.
1 moment
I rotate by 4 bits, right? I rotate by 4 bits, right? God, please deliver me.
Oh yeah, actually the answer can be this. 1 and 2.
What the hell?
Yeah, can. It's confirm correct.
No, I don't understand the rotating part too.
Okay, so rotating is basically, for example, if you have A, B, C, D, right? E, F, G, okay? H lah, okay. So what happens is when you rotate, right, you will just bring to the front. So what happens when you rotate one time, become H, A, B, C, D, E, F, G, like that. Can you see?
So let's say I rotate.
So this is the concept.
If I rotate by 2 bits, then it becomes H, G, E, B, C, D. Right?
Yeah, so it must be even lah. Must be even. So in this case, right, when we rotate by 2, so for example, 1 is actually 0 0 1. 0 0 1, right? And then we rotate to the front, right? By 2, right? So by 2, it becomes.
Still be the LSB leading, right? Even if you rotate it by 2 bits.
Sorry.
Even if you rotate it by 2 bits, the LSB will still become the MSB at the end of the day.
Wait, so actually it's like that, right? 1 and 2, right? Correct. Okay, so wait, when you shift here, so if I rotate, I cannot rotate 1, I only can rotate 2, right? So right, so this is the 0 0 0 many, right? This is 0 0 front. So from here, I rotate to the other side, so become here, right? The one will end up there, right?
10001 and 20,
Yeah, it's
right?
gonna go ahead.
Then you must put one more time.
So if I rotate this.
Sorry, say again, say again.
You rather rotate means the 1 is in the front. That's 1 0.
This right? Then it become like that, right? But
No, we don't
wait, I put wrongly. It's supposed to be like that. Ah. Okay. Sorry about that. Okay, no wonder. I also confused already. That's why I was like wondering why doesn't it get. Yeah.
Wait, does it look like this?
Huh?
The top part of the sample.
This one you rotate by 4, is it? 1, 2, 3, 4. Yeah, correct.
That's what I was wondering.
Yeah. But actually, this answer is the best because it's 1 and 2 only.
Yeah.
But I think 4 and 4 is still fine.
1, 2, yeah, it also works.
So just for everyone's benefit, let's try again. Okay, so we have 0, 0, 0, 0, 0, 0, 0, 1.
Yes.
Okay, then we rotate one time, but in the computer cannot. Basically, if you write in the ARM program, right, you cannot rotate odd number. But I'll just show you odd number. 0, 0. Sorry, it's just 1, 0, 0, 0, 0, 0, 0, 0. Right. This is rotate by 1. Right. So what happens is the 1 go to the front, right, and then you rotate one more time. Right, become 0, 1, 0, 0, 0, 0, 0, 0. Okay. Okay. You ignore right? Here got many bits many bits. Here also got many bits. Okay, then this is actually just equals to 4, and then 0, 0, etc. Okay, this one is not illegal. This is illegal, right? Because you cannot have a even you cannot have odd number of rotations.
Oh wait, so the answer is wrong.
No, this is correct. Okay, so this is the answer. Okay, for the next one, okay, so for this one, right, I think basically try to look for a way to express in the hexadecimal form first, and then see how you can get there. So how do we express this in hexadecimal form? Wait, so it's 0x f f f f d c.
I want F in the front. F D C F.
Y'all sure this is the tooth complement, right?
I mean, we did something, right?
Yeah.
I don't know what we did. We did
Yeah.
something.
We don't know correct or not, but yeah.
We tried.
Okay, so to convert tooth complement, right, we have the value, and then we plus 1, right? Sorry, we invert first, then plus 1, right? Okay, so there is 1, 2, 3, 4, 5, 6, 7, 8 bits, right? Let me see. Yeah, correct. So the answer should be F 0x 1, 2, 3, 4, 5. Then this one is 1101, which is actually D, right? Is it D? 1101 is D, right? Is it? E F, yeah, correct. The other one is 0, 0. Sorry, it's 1100. This is C, right? Okay, the next one is I invert it, then plus 1 is F. Correct, you're right. Yeah. Okay, so this is the value you're supposed to get. Okay, what do you realize about this value? There's a lot of F, right? Yeah, make that to your advantage. So what happened? What is the 3-letter word that allows you to have a lot of S?
MVN.
Yes.
MVN.
Yes. So
How to use?
That's the key, how to use.
Okay, sure. Okay. So MVN, right? So when we move this, what happens?
It's a complement.
So if we move, for example, we move 1, it'll be the complement of 1, right? Okay. So in this case, what is the direct complement of this one? Because basically the MVN is the direct complement, right? So what is the direct complement of it? It's 0, 0, 0, 0, 0. D is what? It's just 2, right? 2, 3, 0. Okay. So from this 2, 3, 0, Okay, this is in hex, base 16. We need to identify the binary version of it, right? So what is the binary version of it? Is 1 0, right? 3 is, okay, I put 2 0 in front. 3 is 0 0 1 1 0 0 0 0. Okay, can we make it even shorter? Do you see this is the shortest you can get, right? Over here. Can see or not? This is the shortest you can get.
Yeah.
Okay. So actually there is a few ways to do it, right? I think what you can do first is this one is 230. What's the value of this one? Anyone know?
Just as that thing, is it?
Oh, this is just 561, right? Oh yeah, you can actually do something like R1 561, correct or not? Is it 561?
But can you really ignore the zeros?
Oh, 560. Yeah,
Can you
560.
really ignore the zeros like trailing and leading behind and forward of the one?
You mean this one? You want to do it? Yeah, can. Yeah, so that's why I'm going to show you the other one. So there's another way to do it, right? You can actually go and rotate, right? Rotate. So that's why I ask you what's this value? What's this value? Okay, I just starting from here until here. So this is 1, 2, right? Right. Here is 1, here is 2, then 4, 6, 8. Right? 1, 2, 4, 6. Wait, 1, 2, 4, 8, 16, 32. 32 plus 3, right? So you get 35.
How are you getting 30, 36?
2 power 0, 2 power 1. I'm trying to shift, so I just take this as the base one, the starting one. You can see. So it's 35. So we know the answer should be MVNR1 35. How many do we need to shift?
32 minus 9.
We need to shift a total of 28.
What is it, 28?
28. Huh? Where you get 23 from?
I don't know.
It's 28, it's 28. It's 28. 1, 2, 3, 4, 5, 6, right? Yeah.
Oh yeah,
so,
because
yeah.
at least you take into account those zeros as well.
Yeah,
I never took into account.
you never take into account these 4 zeros. So 4 zeros, and then here got how many zeros? So 32 minus 4 minus 6.
So 0, 0, 0, 0.
32 minus 4 minus 6 is 22. So here got 22 zeros, right? 22, yeah. 22, 23, 24, 25, 26, 27, 28, like that, right?
0, 0, 0, 1, 1. 0, 0, 1, 0.
Should be right, yeah.
1, 2, 3, 4. So these 4.
Okay, let me double check that. So it should be correct.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
For everyone's sanity, yeah.
I don't think you can save our sanity though. You're making her a bit of a stretch, but sure. Yeah, can. Shift by 28. Yes, got it.
Okay, so how do you get it?
I counted the number of zeros before and after.
Okay, wait.
I did it in a very labor intensive way.
Okay, so where are the zeros?
The ones before and the ones after, right?
Yeah, before, which is 4, right?
Yeah.
Then after is how many?
You're gonna have like 22 zeros.
Okay.
So 22 plus 4 is 28. That's right. So when you rotate
22 plus 4. 38. It's 36.
So you could have, there should be 24 zeros on that side, right?
Here should be 24 zeros.
1, 2, 3, 4, 5, 6,
24 plus 4 is 28.
12,
28
There's
plus
a 6 inside, right?
Okay, you know what? I give up, guys. I do not wish to do this module anymore.
Wait, how many are there? 32 bits, is it?
This is 4.
Okay, so that means
1, 2, 3, 4, 5, 6. 22 minus 6 minus 4. Shouldn't we shift by 26 and not 28?
28 is the correct answer.
Wait, when you say shifted 28, meaning that the entire chunk of 1, 0,
Yes,
0,
I just-
0, 1, 1, you just push them all the way until
You rotate, you'll come back one round.
You
Yeah.
cycle it basically.
Yeah.
Cycle.
because like I was wondering is how do you
Oh, the answer's
understand
28, is it?
Hmm?
The answer's 28.
Yes.
Oh.
Confirm 28 lah. Check your calculator, check computer.
22 minus 4.
Huh?
22 minus 4, that's 78.
decimal format?
Oh yeah. Yeah. It's 32 minus 4. Yes, that's how you get it. Because it's how many zeros you want it at the back.
Yeah.
Correct or not? Yeah, okay, just see how many zeros you want at the back. Because this one, right, how many zeros you want at the back? It's actually what? How many zeros you want at the back? So just now the 4, right? 0, 1, 0, 0, right? Then here got how many zeros? 32 minus 4 is 28 zeros, right? 28 plus 2, right? So it's 30 zeros, right? So it's 32 minus 28, ma. Sorry, 28 minus 30, sorry. Here plus 2 here. So it's equal to 2. So the answer is 2. Right, can see?
These are the 2 zeros before the number.
So this is how you remember lah, huh? Easier to remember. 32 minus how many zeros you want in front of it, or like at the back of it.
How many zeros do you want at the back or the front?
Back.
At the LSB area.
At the LC area. Okay.
Yes.
Thank you.
Yeah, Veronica got figured out.
Thank you, Veronica.
Because it's left shift left.
Oh yeah, you can see that.
Because by default the 2, right, it means like LSL, right?
2 this one is it?
Yeah. It's by default means LSL.
It's actually like that lah. You go here ma. I know.
Basically,
But your
it's
formula is correct. Yeah. The formula to calculate is correct. So it's 32 minus however number of zeros you want, right, at the LSB side.
So it's like if you show it's 35, right? Then this is what it looks like. So the reason why it's 28 is because like as you can see on the left, that's what 35 is binary. If you move it by 28, there'll be 4 extra zeros, which is representation. This is how to get the answer, that kind of format.
Okay.
So I realized that like this 35.
Yeah.
You shift it by 28, that one will stop right exactly here, which is exactly corresponding to this one.
Yeah, correct.
So
yeah, it's supposed to be like
you follow this.
Yeah.
Really good.
Yeah. Okay. So the third one, right? 698. We need to convert it to hex again, right? Yeah.
698.
Yeah, the hex is just 698. Okay. So the hex is just 698. Is there a better way to do it? We convert it to binary first, right?
But why do we need to do that? Can't we just directly move it into the particular register?
I know, but we see if there's a better way, right?
Okay, sir.
Okay, so actually that one is quite long, right? It's just 0, 1, 1, 0, 1, 0, 0, 1, 1, 0, 0, 0, right? Right, it's actually quite long, right? Is there a way to simplify it? No, not really, yeah, because it's also odd also. There's odd numbers in front.
698, that could be 698.
Yeah, so actually, oh, thank you. What do I get? It's just LDR, R1. Like
Wait, what's the difference between using a move or like move instruction instead of a load instruction here?
the move instruction cannot be more than how many?
Yeah, move has a limit.
Yeah, move has a limit.
Let me go see that.
4 bytes, right?
I love how you took this module long back and you still remember it, and I'm just crying here. Was it before or after exception?
Your X46 698, right? Is there a hex in front of them?
This one
Oh,
is hex 0x. Yeah. It's a hex number.
so do I need to send the hex?
Oh, I need to put equal sign. Yeah.
Oh, it's equal sign only.
Yeah, in the programming, you need to put equal sign.
Yeah.
I missed the equal sign.
Okay, so there's something.
Okay, there's a limit. Hence why you can do that.
So this one cannot, right?
How much is this?
I did not manage to find it.
Oh, yeah.
Give me a minute, guys. I'm not that fast.
Which one? Question 3 is it?
I'm human.
I can.
Hi, Veronica.
Hi.
Wait, which question? You said question 3.
I just want to pass, bro. That's it.
Yeah, yeah.
Oh, it's on number.
Oh my goodness. Who am I?
Wow, there's 98 MOVs, guys, in the fucking lecture slides. Wait, I know what's not there. Yeah, I will just continue looking at it.
Yes.
Move. PC.
Yeah. Largest value for move is 255. So
Cannot
you must
solve.
use LDR. That's the worst. That's the best case scenario already.
Yes, sir.
255.
Okay, got it. Thank you, sir.
Move cannot because it's more than number is more than 255. Move only can move up to 255. Okay, last one. 12 marks. Okay, I think this one you can see the pattern, right? No? This C and 3 is very close to each other, right? Right, it's just a shift away, right? Are we able to get C3? Okay, so what is C actually? C is actually equals to 1 what? 1100. Okay. What is 3 equals to? 0011. Okay, so actually there's no way, right, to make it any closer, correct or not? There's no way. Okay, then what is the okay, so this is C3. Okay, what is the binary the decimal representation of this is actually equals to decimal representation.
195.
You check should be 195.
I will take your word for it.
Okay, so 195, right? We need to shift. We need to have how many zeros in front of it? Or we need to shift how many times? There is actually 28 zeros, right? Correct. Or we need to shift 4, right? 4 bits over, right? So the answer is actually just MOV R1 195 shift by 4.
Okay.
Can, right? This one understand, right?
This one I got it.
Okay, you want to try another exam?
Sure, fine, let's go for it. What's the worst that can happen?
Okay.
I mean, I'm already feeling you might as well make that a graceful fail.
But this one is quite lucrative at the marks. Quite lucrative.
Lucrative means about what's going to be steep.
Is then they don't have me? This one don't have. Ah, interesting. Yeah.
No, they have actually.
Where is it?
We checked last year's paper and
You
last
need to basically,
year's paper. There is
like you said,
It's always at
you need to
2.8.
shift it around.
Always at 2.
You need to have 28 zeros. In front.
Not from 2019.
Oh, I just checked this
There
one.
need to be a 28 zero gap. 52 minus 28.
Ah, yes. This one. I have to cut off because my answer is there.
It's like this, right? 1100 But you represent this.
Okay, quick practice. This one should be quite fast.
Oh.
Why don't cry?
I never think of it.
Try harder, bro.
Yeah. I forgot about that.
Try harder, bro. I was supposed to study modeling and control today. I don't see that happening.
Shit, is that hard?
I don't know, bro.
Oh no. Okay, I give you all 5 minutes to do this one. 5 minutes.
I'm just gonna say it because I cannot.
This one should be easy, right? This one.
Move
That's what you said. That's what you say.
hexagon AP by 16.
Very good.
How the fuck do you mentally derive that shit, man?
Because 32 minus that one is AB is what A is 4 plus 4, 8, 8, right? So it's what 32 minus
Bye.
yeah.
By math zero.
Yeah, 8 plus 8. Yes, 8 plus 8.
Low. Second one's low.
Oh yeah, I see it.
It's not even, it's a god
Who was the first one?
Because he's very good, that's right.
No, I'm just having a fun.
Yeah, very fun.
You just have to check whether the numbers are smaller than 255 or smaller or equal to 255. If it's smaller or equal to 255, you can use MPN or MOV.
Oh shit.
Okay, that's the best case scenario. Okay, so I teach you a method, yeah.
It's higher already.
Okay, if anything that is higher than 255, you cannot, then you load already.
Okay.
I mean not load, sorry, it's LDR lah. Yeah. Load is a different thing, right? Actually load also, yeah. It's actually load lah, yeah.
68.
Plus 1.
If you can use MOV or MVN, it's better because it uses less memory in the.
Thing is it? Good to know, sir.
In my brain is
Oh.
My brain is not
In your
there.
brain is.
You said it. Like there's no more zeros after.
Eh? This one?
Yeah.
Oh, it's all 8 already, what?
I'm sorry. Please don't be mad. Please do not be mad. Don't say the answer loud, Spencer, please.
No, I think I want to say that.
Or the third question is very interesting.
I'm still at
No,
first.
the third,
Yeah, so say first.
I meant the first question
The
already.
first question shouldn't take you too long though.
the third is still low.
I mean, it's still low, yeah.
No.
It's higher than
There's so much screaming answers.
The third question.
Yeah, my brain go there already.
Yeah, that's why.
Third question is not. It's not.
Oh, then you go and try.
Spencer, don't scream the answers out.
Yeah, we went back to the space and they come back again.
You should be done with question 1 already. The part 1
Oh
already.
yeah, I don't know.
Give me a minute of silence.
Give me a minute.
Are you sure question 1 is not?
Oh,
Question 3 is not.
Who am I?
Yeah, question 3 is not low.
Don't say that out loud. We all of us haven't figured it out yet.
I'm stuck at question 1.
I'm at question 3. Do not do this to me, please.
I'm with you.
Spencer,
You
but
don't
you're
want to
screaming
do
the answers out.
I'm the child.
You're ruining my discovery journey.
But you tell me really shit.
Your discovery journey is faster than mine. Mine isn't.
No, it doesn't matter.
Fuck off.
So part
when
1
you do the
okay.
paper, I will blank
Not
Still
sure
stuck.
how the shifting.
I will also blind with you, bro.
Oh shit, why is it
I
really?
did-
Okay, how many zeros are here? How many zeros? How many zeros
That's
here?
Four.
No, it's not 4. It's not 4. It's supposed to be 8. It's supposed to be total got 8. 8, right?
Total.
Right. A, B, then 4 zeros, and then 2 more zeros, right?
Wait,
right.
I can't do this in
No, it's by right, it's
decimal.
the full thing. This only give you halfway only. You get
Are
me?
the zeros in front?
C, zero.
Oh yeah, zeros in front.
Yeah.
Oh yeah.
Then,
Confused.
Did I get it wrong? No.
Wait,
Oh, the zeros are in front.
Give me some.
Oh, that's not 16 already.
What is going on? Why
No, it's basically see how many zeros at the back, right? And then you minus, and then you get the, then you know how much to shift already.
Then,
As
for
simple as that.
instance,
So this is
Binary low.
so does it mean you shift it by 30?
So it's 1, 2, 3, 4. 4 zeros. So 4 zeros times how many?
16.
Times 4, right? So 16, right? Oh, it's 16 so because it's even.
What the fuck?
It's even each.
What the actual fuck is going on?
Okay, it's correct.
You guys are making my brain hurt.
Oh, I always doubt my answer.
I'm
So
back
it's
to the
shift
second
16.
question because of you guys.
Because of how many zeros at the back? Got 4 zeros, right? So got 16 bits, right? Yeah, so you just put 16 at comma 16, and then the number is AB ma.
So the number.
Yeah, this one should take you like less
Is it
than
like that?
1 minute. Yeah, correct.
Okay. Oh,
Wait,
okay,
I'm now
it
back
makes
at the
sense
third
now.
question. Let's do
Second
this.
question.
The second question is
Slow down, slow down.
You got the first question, first part.
Let's see what it is.
There's no such thing as hash AB. It should be a number.
Oh, number.
There cannot be hash AB. That one is you also put a decimal there. I think you're all very weak at this question.
Wow.
And this is a lot of marks though. A lot of marks.
This one, 0x,
Uh-huh.
and push it back by 26.
Can.
Okay, so that means it.
But why
But
is
it's no.
It should be
Correct, but it's 255.
it's out of the range already?
The number is-
Question two. Question three. I don't know. Write it down.
no, because
This is the answer.
because when I change this, that was.
Yeah, you're right.
Finally.
I don't know what's going on with that part.
I'm still
Oh yeah, then you get one.
It's stuck to one.
Yeah. Yeah. You're correct. Exactly. So this is what lot? Like 2, 4, 6, yeah. So 6. Yeah. Correct.
I don't know what the name means for that.
Come,
Sure.
I see the numbers so often. Oh, you know why? Because I pressed this there, I assume that it was.
Yeah lah, no. Okay, wait. So which part are you at now? Still 3.
I don't know what the fuck's going on.
Okay, so remember the step, right? Is always to check whether is it more or less than 255. If it's
This one is
more,
more than 255.
yeah, if it's more, then you have to use load already, right?
But I said load, you said no load.
What? You're talking about 3 or 2?
3.
3 is not low, it's more.
3 is more than
It's not.
it is.
You have to find the one that deletes all the zeros. Find the component, the part. Obviously, this number is more. Obviously, this number, but you have to try to find the in between. Don't cry. Leh.
Thanks, harder.
Mhm.
I just want to like go home and sleep. I don't want to do my cookie anymore.
Actually, we're going through the easy questions.
Trying already lah.
Question 2 just look okay.
I want to
Yes,
like
yes,
shuffle
just
this
look.
and take like another year 3 elective and call that my elective. But then I need to extend. Should have taken photonics too.
Assuming the fourth one is not
C.
moved, right?
Cannot be.
Yeah,
no
then
choice.
that means it cannot be R. Because
Yeah,
if
yeah,
you
yeah.
try to move,
Cannot. You cannot, right?
No, I saw this. When
It's so far away.
No, yeah, no. When I push back by 2, Q will be
So
here.
I
It will be
eliminate
here because it's
okay.
corresponding.
Yeah,
But I
yeah,
realize that
Then I check
it is like it's also uneven in a sense. Because usually even it always has to be way two spacings or something.
Yeah,
Because
yeah,
it's an odd number.
It's too far lah. It's too far.
Yeah. So
Oh,
that
it's
one
not.
is
Problem-
It's not
low.
exceeding. That's why.
It's definitely that, but I think there's some way lah.
I just don't answer that. But I'm a bit weak on the MVN part. Because it's the whole you need
You have to
first-
convert to binary first, then you from there see.
Correct. MVN, the basis of MVN is you convert it to binary first, then you
Just
minus by 1, or is you
No, just invert.
straight,
Just invert.
invert
only.
straight
There's
away.
no minus. Just
So you invert straight away.
Yeah.
Let me check. I should know. Okay.
Okay, this
Binary.
answer does not look right.
Ooh. Wait, how do I remember all the zeros? Second and fourth.
So 1, 2, 3, 4.
Oh, I'm looking at the wrong thing.
Minus. I am tripping. I am really tripping. 52. Let me feel my cookie.
Which part you are at now?
I am nearly done with 3, but I don't think I'm doing 3 right.
3 is very interesting.
Why?
Wait, which part are you at now?
I thought 2 and 3 almost the same.
It's different, totally
It's
different.
different. It's different.
But you done with 2 already, is it?
Yeah.
So okay, then the 3 then you have to
I-
write in this. You have to write in hex first.
I think
no,
it's
sorry,
the
not
same
hex.
method as
Binary.
Binary.
4, 0, 0.
When you look at the binary, you see whether you can remove everything first. You see what's in the middle, and then see whether it's less than 255 or not. Less than equal to 255.
Oh, like
Yeah,
not
yeah,
as
yeah.
a whole. Oh, okay.
Not definitely not as a whole. What is that? Oh, interesting. Where got such thing one? Where got such?
Singapore artists,
Oh,
it's towards art side.
okay. This is very nice. Oh, I think I'm gonna put on my laptop.
The third one's interesting.
Okay, you got it already?
No, I did not get it.
No!
Screams in agony.
How can 3FC hexagon can result in decimal of that number? Because when I convert, it's not right. Then when you do the shifting, then you lose.
It's a very peculiar case.
That's the beauty of it.
Hey,
What
beauty,
beauty?
I will lose marks in
I
finals.
spend 5 minutes staring at it and I assume it's not the number.
1, 2, 3, 4, 5,
Yeah, it always
6, 7.
gives that very big number.
No, always convert to binary and see from the binary perspective.
What the fuck is binary, bro?
The binary perspective
Wait, so
is like that.
MOV 255 still can.
Yes.
Over 255 cannot.
Cannot, yeah.
7, 5, 6.
So you got it already lah?
Roughly.
Okay, good.
But then binary perspective
I was like,
show you
saying
this
something
number
like that.
unless until you do the
Yeah,
shifting.
then you just cut out this one. You just cut out.
Instead of like,
Yeah,
So Veronica, which location are you at now?
24.
Yeah.
So should be 24.
Yeah, I think I haven't asked.
The
Look behind. How many zeros at the back?
zeros
It's 2 and 3 like that. 2 and 3. You keep laughing.
Double check here.
What's that? Oh my god, so cute. What's the point anymore?
What is 12? 2 cubed 2 square.
The moment right now is we do this paper.
Why?
Why? Okay, okay. Oh, let me try that.
Oh, my head.
0, 0. So you take this, right? And then this is gonna be less than 255. Yeah, then 0, 0, 0. 0. So 6 into 4. 24.
Why?
32
He's shaking his head. He's shaking his head.
32 minus 24, right?
Number 2 cannot. You cannot
number two
represent.
cannot.
You cannot represent a number more than 255 like that. You must put in hex.
Oh.
I mean, to be fair, it's already in hex.
So I cannot just load like that.
Hmm.
I cannot just use LDR and load like that.
Cannot. Yeah, and the number 3 is also wrong.
Also.
Yep.
Why?
So 32
You're very close. You just made a mistake. Somehow.
Why?
Super close.
Is it shifted by E in the case of number 3?
Nope. It's opposite of 8.
What?
32 minus 8. Eh?
34.
No, not 32 minus 8. Is
6.
32 minus 6.
Yeah, 6.
Yeah. How many zeros at the back? How many zeros?
So let me count.
Zeros really expensive.
1, 2, 3. There's 6 zeros at the back.
Yeah, so 32 minus 6.
That's how much you should buy.
Yeah. Just use that formula, just use that method to do, can already.
So my one was because the zeros
You missed out how many? You missed out another, I think you missed out 3.
no, because I did 6 times more. Then I forgot I already expanded it. Then I was like,
Oh,
ah.
okay.
So should
Oh
we-
yeah,
It
you're
was
going
6 zeros.
to
It was already 6 zeros. Yeah.
You was already 6 0.
Oh,
already.
that's
You already got the
right.
answer, you just
Yeah.
careless mistake. Okay.
So basically, when you shift it forward, kachang the rest. You just
Yeah.
shove it out.
Yeah.
Get out of here. I don't want to know you anymore.
No.
What?
26.
6?
Yeah, this is
Oh,
everything quite
man.
different. Remember this now, yeah. Okay. Then this one, this is part 4, yeah. No, this one, what is this?
Hot, right? So I can just
2, 0, 0, 1, 0.
Okay. Are you sure it's 217?
0,
Are you sure?
Oh, wait, there.
How was it? How was it?
Yeah, you're smiling and stuff. Yes.
I don't know, bro. He smiles at anything sometimes.
No, this is pure blissful smiling.
Are
now,
you-
now it's just.
Did you do well?
I don't know. I really have no
It's
idea.
confirm more
what's
than
going
255. Confirm
Did
more
you
than
do something?
on. I have no
It
idea
needs,
what's
it needs to
going
be
on. I'm just
evenly
writing my-
spaced.
As far as I know, that it's
Every 2
correct, I'm
bits.
just writing.
Okay, good job. That's all you needed to get done.
Yes.
1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4.
What do you?
Evenly spaced, I remember. So it cannot. It's not 217. It's actually more than that. But it's her thing.
Which one? What's that?
Number
No.
two, right?
Ignore. It's not 217. You put 217, mate. No what?
Isn't it?
No, cannot be MOV. You see, you see this one, right? There's no way that you can cut. You must cut at even position.
Oh, okay.
Yeah. Every two bits.
Then you
cut.
exceed, okay.
Yeah, then you exceed, and then you cannot use MOV already. I thought just now you got it correct.
I don't know, you see wrong.
You no, wrong is the hash cannot use hash. Must use because this is too big already.
Oh yeah, hash
Too big,
is.
but less than 255.
Oh, okay.
So if you cannot, then just give the hex value.
Oh, okay.
You just need to change one thing only. Nah, actually, your one is almost correct. Yeah.
So it's just.
Just change one thing only.
So it's like that.
Yes. I put equal sign
Okay,
behind
let's
in front of
Oh
the zero.
yeah.
Let's see this something.
So when you load R1, comma, equal sign 0x6c8, is the equal sign is necessary.
For program, yes.
But if I were
I'm
to
sure it's not right.
put it from 6c8, I convert it into decimal form. I don't need to put the sign. I just need to put the hashtag decimal number.
As long as it's smaller than 255 and 68 is more than 255.
Yeah, 6c8 is more.
Yeah, if it's more than 255, then you cannot put that already.
There are 4 questions. What the fuck? We're still at the second question?
Can't go home already.
No, I want to drop this module.
You're so close, you're so close.
I don't need
This
to
one?
take this.
Oh,
I
which
chose
one?
this
This one is not 217, right? Just
What
throw
the
this
fuck
in.
is wrong with
Yeah,
me?
just throw in then
Oh,
done.
okay.
That's, yeah.
This
I'm
one,
asking.
then this one,
Correct.
this one,
That's it.
oh,
Can't do anything. I can't see a way to do anything. Okay, are y'all done already?
No, last one I cannot.
Last one cannot, then just LDR then that one. Let's see.
Yeah.
He speaks the truth.
Nah?
He speaks the truth. Because we're converting that hexadecimal to
Because there's 8 bits.
decimal.
There are 8.
I wrote the bits down. I was like, this is definitely not 255.
Yeah, and there are 8 bits in between each bit. So it's like it's basically
Cannot go. No choice.
yeah, you can't.
Okay, I get the entire logic of things. Sorted.
Okay, any other so this one okay?
But
I
then
don't
the
know.
number 4 can do MOV.
Number
Or
4
not necessary.
cannot at all.
Cannot.
Yeah.
This 255, it's above 255 already.
Oh yeah.
So cannot MOB already.
Okay, one more chance for redemption.
Can you have me move Veronica's toe? I
Oh,
cannot see.
Okay, this is one more chance for redemption. 5 minutes.
But thank you.
5 minutes.
You have 5 minutes.
Too fast, too fast. Can you give us 10 minutes? One question always 30 minutes. Then you conform another.
How long do you think to do each one? Should be very simple, right?
Not that smart. First one.
You recognize this one. This one is definitely easy. This one you figure out. Then this one you know already, right? This one you did before already. Just different shifting only.
Oh, okay. You should. I already told you. Yeah, very confusing.
Then you take more time here. NBA will take the most time, I feel.
Plus, it's like you need to play with your head.
Yeah. Okay, this one, last chance to redeem yourself. Only no more question already. This is the last chance to redeem yourself already. Last chance to redeem yourself.
Who said I needed redemption? I am accepting my failure to do questions. By how much? Yeah. G guys, it was nice to you all.
You can check whether it's more or less than 255. If it's more than 255, then you have to do other method.
Okay, that one need to do.
So, but now you should be faster already, right? So 5 minutes should be done already.
No hashtag. No hashtag. 0, 0, 0, 0, 0, something.
Redemption round.
52 minus. Did I count it?
I don't know, give you more confidence.
You suck.
You just check, you just see again this one. Oh, actually, not very correct also lah. It's not correct. Just 2, 2, 1. Yeah, exactly. Yes. Correct. Cannot. Must be this one, right? Must be even number. Yeah. So it's just 2, 2 lah. Just 2, 2 lah. Yeah.
Isn't that the same as before?
CFC, is it?
Yeah.
That's what I do. I won't. Because that one is your.
If got this kind of question, confirm. Confirm one.
I mean, you went through. You went through.
This one is
Sem 2,
also.
Sem 1 of 2021.
Yeah, I went through everything.
That means the bottom one is always the same.
It's the same, yeah. It's usually. This one is actually very easy, one. This one you just convert, just invert everything. Then after you just do the exact same method.
You remove the
As the MOV.
remove the zero, find the number.
Exact same thing as MOV again. Exact same thing as MOV again. Yeah, it's just invert only. Then you just put MPN only. That's all. Yeah.
32 minus that. Oh, my number not even. My number. I don't think I can redeem myself. I'm losing these marks.
And this is a lot of marks, like 12 marks.
I know. I can't
For
do
these
it.
4 parts, each one 3 marks. Quite good. This one.
I actually don't mind throwing away the 4 marks for the IE3102 like this one. Because that one you need to memorize 2 to 3 formulas.
Oh.
This one is the same as before.
So I believe y'all should be at 3 already, right?
I'm at 3, yes.
I went to Malu too.
Oh, okay, yeah, makes sense. You got time delay. How I ask you.
Enough of propagation delays.
Oh. That's it.
What the fuck is that? How many zeros at the back?
6 zeros.
I'm asking myself.
Oh.
You.
Oh.
I'm not
But I'm
asking
just telling you the answer.
I doubt that's the answer. Sure.
It is. No, yeah, it is. Hey, wait. Oh, it's just 4.
Yeah, that's the thing. Why are you playing with me, sir?
It's
What's
a
the joy in
good
playing
way to test the knowledge.
smiles and pains?
Exactly.
Mouth and pains.
Should not have taken microprocessors in the hindsight. I'm more scared for this than image processing now.
Yeah, this one don't need size.
Stop lying, so stop lying to yourself, PP.
What?
That's what I say for every single mod.
You also see that what?
Monica.
What?
Tomorrow and Sunday I gathering people to do split cheat sheet together. A cheat book. Book or some nonsense. Cheat sheet type one. You want or not?
I want, but I
They allow you to type.
Okay, I'm done.
So good.
Huh?
They allow you to type it.
Right.
Okay lah. Wow, everything. Last time cannot even type, so sad.
Okay.
So you asking me to show me is it? What time?
So
Whole day?
how? Oh, you meant to reach the last one.
We've done this previously, the last one.
Yeah, actually I don't understand.
Okay, the last one, right? Okay, just a clue, right? You just invert and do exactly the same as MOV. Just invert it. Just invert all the ones, right, become zeros, and 0 become 1. Just invert first. And then everything do exactly the same as MOV. But in this case, you instead of writing MOV, you write MMV only. MVN, I mean. That's all. Yeah, that's all only. Nothing else. As simple as that.
Okay, I will try to be until you guys to see if I'm as lost as a cause.
That's all. It doesn't rhyme. You understand where I'm coming from?
I like because this is the final format. The initial part is get number, shift it to a point to there.
Yeah.
And combine it upside down together.
Yeah.
This one, I
It took me a while to process.
It's not. It's nothing difficult. It's very easy. It's just just invert only.
That's it.
Just invert, shift, then done. Yeah.
That's all for microprocessors.
No. Screw you, bro. Genuinely, I should have taken some physics or math module.
I might take this when I come back.
This is 2-2.
Let me
Double check my work.
answers with you. It'll be a shame if I got all of them wrong.
1-1 lah.
Second is right. Third, not right.
Why got now got no motivation? It's okay lah. If it's careless mistake, it's okay because the answer you can just double check. But as long as you get the concept, it's fine.
Can you explain the third one?
This
Why
one?
is it 30?
Why is it 30?
Yeah.
Because
Oh wait, I know why it's 30. Never mind.
oh, yeah.
Sorry.
Because there's 2, right? 32 minus 2 is 30 ma.
Yes, sir. Watch me fail, guys. I'm gonna actually thank the work of the test.
Why is it 35?
That's what you said for every single
Where?
mod.
The
This
last
one?
I'm actually
I got
thankful for this
23.
one and say yes. not gonna
DCF when you convert already, right? D is 1101, right? So become 2, right? 10, right?
Yeah.
10, and then here is 001. So it's 1001, which is should be 35, right? One.
I don't know.
Spencer,
I
I
think
don't understand.
100011. This that one is C, okay? That one is C, okay.
Then
That's 23, man. Is it?
I have
1
0,
plus 2 plus 4, 8, 16, 30.
then
How can it
since
be?
I need to bring this
This is
down here,
32 and not 16. I think you add 16.
Oh, yeah, it looks like from the
It cannot be also.
No, but
Because
even
it's
if I
L1, right?
simplify, it will be the
1 plus 2, correct? The third, this one, this is 1, 2,
Thanks for my
4,
forgiveness.
8, 16,
Okay.
32.
Oh.
Yeah. So confirm
Okay,
is more than 32.
I forgot it was binary.
Or what do you
I
add?
treat it as like
Yeah, binary
Like-
will be like this, right?
like
You can-
4 then it's
or you just
Inside
add.
decimal,
Oh, okay,
yeah,
okay.
yeah,
You can just like-
Yeah. I think these are all the careless mistakes. But as long as you understand the concept, I think you got it right.
Finally.
Okay, so this one should be clear.
Okay. Got it.
There you go.
Number one,
we
can
So
use
it's easier to just like.
Number one.
I thought it's
And now
looking at
like the starting
thought-
point is
I
where
thought it's looking at the overall.
Correct. So this
Like the
is like
255, I thought it's
final
looking at the
outcome we
overall.
want to get to using what they have. So
Oh, you mean this one?
Yeah, like the reason for MOV and LDR is MOV cannot use if it's more than 255, right? Then I thought 255 is we look at
I gave you
like
this
that.
This whole
Where do
thing.
we look at for the 255?
No, we look for the even placing between. So that means here, right, is actually 0, 0, 1, 1, then 1, 1, 1, then this in between right, right, is actually just nice 255. Yeah, you can cut.
Only
You must cut
at that.
at the even, yeah. So if you can do it that way, then you can actually replicate this through this command.
Oh, okay, okay.
In binary, you must use
shift it in that case, right?
by like usually if you can put two cats, but you know how the system is different. So like imagine you shift all these guys to the starting point here. So it's 1, 1, 1, 1, 1. So it's like in hexes, it's F.
Yeah.
So if I want to push them all the way, it looks like this. So I either do things I remember this, you count how many there is, or you just look at this. There's 2 only.
So if I feed 2 minus 2, then you shift by that much.
Yeah.
Okay. Okay.
Hey, the 3FC, yeah, you can see in decimal format 255 is by 30.
Yeah.
That's the answer. Because because decimal 255 is binary or in hexadecimal FF. Yeah.
Okay. I'm gonna go there.
Mm-hmm.
So is it like because I want to shoot this and then the back no zeros, that's why it's 2. But then because this case there's like 2 zeros behind, that's why it must be 32 minus 2.
Yes. Because this is 30 zeros, then this is 2 zeros.
Okay.
Yeah. Okay, so this one I believe all of you are masters of it already, right?
No.
Huh?
It
Really?
barely counts, bro. That's it.
This one you should get full marks already. Yeah.
Careless, I can.
Okay, just careless is fine. Okay, as long as you know the method.
It's careless or I don't know the
As long as you know the method. If you don't know the concept, just check whether is it 255. If it's less than 255 or less than equal to 255, you can do the MOV method or MVN method.
Okay.
If it's more than 255, then just load it.
Okay.
Right? But load you can also do the shift and whatever lah. But usually you can't do much lah.
Mhm.
Okay, yeah? Can ah?
Okay. Right. Let's look at question 2 part.
See, they're trapped with me.
You will couple later.
Not on the module, right?
I don't know, bro. Really depends how my modeling and control goes.
Yeah, I didn't even do this. Oh, okay.
The arm assembly preventions integrated uses some of those methods.
Okay, just look at the errors, right? Okay. Okay, we just go by one. Okay, this one any error or not? Okay, looks okay, right? Area, there's no comma here, right? Right. Here need to have comma, code read only, right? So like that is correct. Entry is okay, right? Okay, this one is it okay? Why? Okay, the list must be equal, right? So here must be equal sign, okay? Okay, MOV got anything or not?
Hashtag, right?
Yes, number must either have a hash or equal sign, right? Hash is for
X.
no
Constants.
decimal.
Oh no.
Equal sign is for
X.
yes. Okay, MOV2 is same thing. Okay, then we look at this one. Loop. Any issue with this loop or not?
1 second, I'm still not done.
Loop is compared with which one? We need to match loop with.
Oh, the capitalization.
Yes, very good. Okay, so this one either we change the other one. Well, so we can change this one lah. Same it's the same. Okay, so now we go here. Anything here? Any issue here?
Wait. Is R0 and R1 inverted?
R0 and R1.
Yeah, in the LDRSP.
This one?
Yeah.
I don't think so.
No, in the
here?
LDRSP R3. Should it be LDRSP R3, comma, bracket open R1, comma, R0?
No, it's okay. This is the address one.
Yeah.
Then this is we put inside.
Add R2 by R3.
Okay, nothing. Okay, this one? Also okay, right?
Yeah.
Then this one?
Not okay, right?
Why?
Should be, because it's either should be CMP or CMN, right? Why is
There's no S, right?
There should not be any S.
Okay. Okay, and then they are supposed to what's the code supposed to do?
Sum up the numbers.
Sum up the number. How many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct or not?
Yeah.
Then here then?
Index is wrong, so it should be 10.
Okay.
I'd like to ask, does stop looks weird?
This one? Looks weird. So anything?
Are they supposed to be in the same column?
No, this is okay.
Yeah.
Yeah, this is okay.
CCD signed by.
If you don't believe me, I'll double check.
Is VLP right?
What?
Less than, that's correct. It's right. Okay.
Okay, check everything else. Is everything else correct?
DCD? Isn't it DCD?
DCD is for 5. Hey, yo. No.
I mean, when I in the exam.
Oh, yeah, sorry. Here's supposed to have ADDS.
That's everything.
Why S?
Oh, so check over.
R2, R2, R3. R3 load. Yeah, because there's negative number. Look at the DCB there. There's negative numbers inside.
Wait.
But the add don't have to be CS. Why? The add. Why this one don't have to be?
Oh, because that's the increment.
That's a counter, right? The
Yes, counter. There's no
counter
negative number, right? So you don't need lah. Good.
R2.
Can right? This one. I hope this one very very clear, right? In terms of understanding it.
Wait, so when you add the S, you're asking me to check the carry of the thing.
Yeah, because whenever you have a negative number, you should use the correct way of doing the calculation.
Because if you just put ADD, then you just add it in. Later the outcome is different, right?
Okay,
No, as in it
nothing
activate
else
the wrong
on
flag.
the graph.
No, yeah, that sounds right.
Okay, that's fine.
Is DCB supposed to be a thing?
Yeah, DCD is a thing.
Oh.
There's DCD, there's DCB, there's DCW.
Yes. I don't think people use W though.
Yeah, because everything else also in bytes now. LDRSB.
I think W don't want a computer, but it's actually it's an actual thing.
Compute the total size of the corrected program code and data in bytes.
Yeah. So how many do you think it is?
1, 2, 3,
Actually, I don't know how to do this.
4, 5, 6, 7, 8. 8. But then need to plus DCD, so each of them has 25. 8 plus 10. Wait, what? So
How do you count it?
I probably will be wrong.
This time
72 bytes?
Small it, I understand.
Neither do I.
Is it 72 bytes?
No.
How do you?
Wait. Wait. I think so. Wait, let me see.
Fancy, you're like killing this module.
No, I'm not a favorite. I'm just whacking numbers for fun right now.
You're whacking numbers.
Yeah. Cause from here is
Yes.
here to here is like 8.
Yeah. Give me a second. I just want to double check my answer.
Each has a 5 plus 4, right? So I just assume that then talk to me.
Advanced to.
It's watching.
Yeah.
Okay. Oh. Wow. Why got extra? Let me see. Then type somewhere.
Maybe I'm wrong. I forgot. Do I need to add the loop? Oh,
5, 6,
How do you
7, 8,
guys find
9,
the size?
10.
okay. So every command from starting from entry onwards would always have 4 bytes. EYTES. And then the bytes will stop as soon as it hits stop. So usually.
So 1, 2, 3, 4, 5, 6, 7, 8.
Yeah,
is it?
and then 8 times 4 because
So that's
1, 2, 3, 4, 5, 6, 7, 8.
4, 8, 12, 16, 24, 28, 32. So
Yeah.
right here. However, you need to count BCD.
B-
each of them.
B also have
each
plus
of them
4.
Take each. So each.
1, 2, 3, 4, 5, 6, 7, 8, 9,
Yeah,
10.
that's also.
So 32 plus
Right.
40, yeah.
Yeah, I could be
72.
wrong. I'm just testing number.
Okay. So as you mentioned earlier, right? It's correct. Every of these, right, is 4 bytes. So 1, 2, 3, 4, 5, 6, 7, 8. This one is also one more, right? So this is 9,
Oh.
right?
Huh. Oh, is
This is B, right? Means this is 1 byte, correct or not? So it means that this is 4 bytes, this is 4 bytes, and this is 2 byte, correct or not? But for the instruction set, right, it must always be in 4 bytes, chunks of 4 bytes. So there's always a padding. So it's padding of 2 bytes also.
Oh. 9
So this is 4, 4, 4 like that. Okay? Yeah.
I don't get the DCB.
The what?
The
DCB?
DCB byte thing you just said.
Okay, B is how many bytes? 1 byte, right? W is how many bytes?
No, wait, W is 4 bytes.
Yes. Then D is how many bytes? DCD is?
DCD is just the half word, right? Or
8 byte, 8.
oh, 8
DCD.
byte.
DCD.
Okay, DCD.
Yeah. DCD is 8 bytes. DCW is 4 bytes. DCB is 1 byte.
Okay.
Then what's 8? Then what's 2 bytes?
DC. Is that even there?
Should have, right?
DCH?
That I remember. I remember there was, but it was a very specific thing.
This DCP is 1 byte, 1 or more byte. DCW is 1 or more half words, which is 16 bits.
Yeah, so it's 4 bytes.
I
16 what? 16 is 4 bytes. 16 bits is 4 bytes.
stop with my entry 0.
1 byte is 8 bits.
Yeah. So
Yes.
16 bits means
Oh,
it's 2
16
bytes.
bits. Also, this CW is 2 bytes.
Yeah.
Okay. Then what is 4 bytes?
Won't that be a DCD, which is 32 bits?
DCD is 4 bytes.
32 bits.
Oh, DCD is 4 bytes.
Yeah.
Okay. So I write here. DCB, DCW, and DCD, right? This is 1, 2 byte, 4 byte, 8 bit, 16 bit, 32 bit. Okay, that's very clear, right?
Okay. So then, in the case of the DCD here, won't each of the numbers correspond to 8 bits?
8 bit.
I'm asking. I don't know. I'm asking.
I think bit of
Deja vu, is it?
no, I think it's all haunted right now.
Give me 1 second. This one is
Why don't we just run the code?
But you won't have the chance if this comes in the final or something. You won't have a laptop to run a code.
Yeah, but it helps to understand because every time you press the command go down and then repeat, so you see the number of bytes accumulating, or you can say a number of bytes with each process until it hits 10. So you'll be able to see and understand like why and where it doesn't take a byte in and when it takes a byte in.
Okay, I'll run the code tonight then. But I want to understand it mathematically.
You might want to look out for what tutorial like. There was one time that something Tom said during the tutorial that the byte is very specific. Bytes is equivalent to 4
36. 2 7 plus 7.
I don't know, bro.
I only get the first. Up to the
Nine,
stop.
yeah, I only get that.
Yeah.
I'm waiting for the PC something. Yeah, that.
Only 48 bucks.
Okay, so
Is it calculated?
it's okay, it's okay. My precious calculator. Okay, so let's look at this. Okay, so we added until here, right? There's how many bytes in total?
36 bytes.
Right, 36 bytes. Okay, and then here, how many are there inside the memory?
There's 10 of them, so won't it be 10 times of? Won't it be 10 bytes?
Yes, but it must be in blocks of 4.
Why?
Because of the instruction set. I mean, the way they store in the memory, right? They will just allocate 4 bytes each.
So 36 plus 12 is 48.
Does that mean there's like 3 bytes? I don't know what's going on.
What do you mean?
Okay, just want it in groups of 4.
In groups of 4, that's
4.
4 bytes.
So that's 12 bytes basically.
12 bytes, yeah.
12 bytes, yes.
Wait, so 36 plus 12 is 48, right? Or am I like forgetting something?
No, that's 48, you're right.
But okay, here's the weird part. What if we also need to consider the loop? How do I actually loop them?
Loop should not be considered.
Because if you have, then your bytes will increase based on how many times you run. So
Yeah, and that's just a fucked up way to have memory management.
that's 48.
The answer, you know what's the answer?
Yes, sir.
Is actually 52.
What the hell?
Can you miss one out?
I checked on the computer. It's 52.
Wait, we missed one out here. Let me see the final.
The 36 is the 32 here is correct.
36.
36 is correct, confirm correct. The 36 is correct. But here, somehow everything becomes 52. So I'm checking why.
Wait, did you just say 52?
Yes.
Okay, the guy who wrote this paper said 50.
Confirm correct. No, the confirm cannot be 50. It must be 4. Confirm wrong. Confirm wrong.
You know how we're all just Is there like a literal pool or something that we are missing?
I want to see a zombie.
Yeah, my brain has become a zombie. The modeling and control after this one. I'm now getting more stress.
Here the sound coming from the characters. My times 4, correct? Literal pool is 1 times 4 and then plus 10.
Wait, the data it says is 10. Then what's the literal pool?
DCB? Could DCB hold on, let me see.
DCB is 1 byte. That's the thing.
Okay, that actually makes sense. Because if he
Oh,
said
48 plus 4.
52.
52. Got it.
How do you get it?
literal pool, or is whatever this dude wrote.
Yes.
He
So
said DCB.
DCB, the command itself will take up 4 bytes, right?
oh, LDR.
Like
I'm trying to check whether that's correct or not.
Because this guy here says 9 times 4, then 1 times 4, then 10 times 1.
You do some fancy maths.
36 plus 4 plus 10. It's 52. Wait.
Yeah.
Yeah,
so-
because this guy actually did not consider two bytes.
Oh yes, so this is actually itself is 1 4 byte also.
yeah.
Okay,
it
so
becomes
did we get the correct answer?
Yes.
Yeah,
got it.
36 plus 12 plus 4 is 52, correct. Okay, so now I know how to get also. Because I think I did the exam paper, I also did wrong. I put 48 bytes because I missed the DCB. Yeah, so it's a literal pool, right?
Oh, don't worry, this guy wrote 50.
No, the 50 confirm wrong. That means his understanding is.
Everything's correct except for his data. You need to turn up 10.
Yeah, that one. I think that was one of the harder ones to get usually. Yeah. Alrighty.
Are we ever going to get this paper done today?
Nope. Thanks for go home.
Yeah, no.
I need to start modeling and control today
And
and
also-
finish the last lecture. for
Okay,
this
so
month.
we just try to finish this question first. Then I'll just give you all some tips. Then after that, we see whether got other time to do other parts.
If the questions I get stuck in, can I text them to you?
Cannot finish the whole thing today lah.
We'll be here
as in,
till like 10, dude.
No,
you want to finish the whole thing? I want to go home.
If you can finish your thing, she will at least be half prepared for the coming Thursday. So the test paper on Monday.
My paper is on Wednesday, and then I have another paper which is this one on Thursday.
Oh,
Same as well.
so what? Do on Wednesday?
No.
If you want, what
we
we,
can.
Tuesday.
I don't mind
Tuesday.
coming here tomorrow and day after if you can save my time.
So when you want to do?
I'll be here the entire weekend. You wanna come and help me? I'll be grateful.
The Saturday I'm booked.
Sunday,
Saturday I'm booked.
Oh, sorry, yeah. Sunday?
Sunday. You want to do Sunday?
I'll be in garage anyways.
Then what about the rest? I don't know.
After 10 o'clock day.
I thought
this one checks
cause she
schedule
got
for
cause she got exam.
Monday
So you got paper on Monday, right?
Can we do Tuesday?
So Tuesday lah.
Yeah, yeah. Then I do modeling control all before, or I do all of modeling control on Monday.
Yeah, I'm also not gonna touch.
Then Tuesday,
Is
the
you also
fifth.
modeling control? No, mine's semicon.
But Tuesday I have to do it like before the evening.
Yeah, 9 a.m.
Before the evening. So it's like morning to afternoon.
I'll be here.
So morning to afternoon okay, right? Tuesday.
I got exam on Tuesday 11.
Tuesday.
Also after 11 lah. Okay. So I think what we can do is we can meet in the morning and then practice a bit. Then after you come in the afternoon, then we just finish everything.
And if you have any
Can.
doubts, we just bring it to you.
Yeah.
Ooh,
So they'll be more efficient for everyone.
Fucking crash off my power.
I have to crash
Power
course this and modeling. honestly.
I don't know lah.
Oh,
Electro.
You just come after your exam.
Yeah. Why I don't remember that?
Line 7 use procedure. Okay, so I think the rest of the part you all know how to do, right? Because they ask you to show the values, all this. It's just to go through only.
Wait, for R0, right? It'll be an address, right? How do you know address?
R0.
Yeah,
R0 equals to list.
yeah.
Or is it so? No, it says when the stop label is reached. So the last value of R0 should be -10.
What do you mean by
Oh,
the
but R0
list?
is
This one?
only
The list is here. What?
No,
Yeah,
you must
R0
be
minus 10, yeah, right.
the total size of corrected program. So now the whole thing should run perfectly to the end. So you just need to see what is the end value of all the resistors.
You're smart, Spencer.
No, I want to fail this.
He doesn't resistor.
Yeah, he says resistor instead of register.
Resistor.
Register.
Monkey brain.
Fuck off.
So are you
Hey,
negative
it's like
stuff?
this thing.
I think I should just
I want this one.
maybe after modeling control when I hit the question, yes.
Okay, maybe I'll just quickly run through the last part. Okay, I won't go through the question itself, but I'll just run through like what you need to know in terms of like because there is you know the ARM and thumb, right? The 32-bit and the 16-bit instructions, right? Instruction sets.
Not right now.
Okay, so for this ARM and thumb itself, is actually there is a few things that you need to know lah. Few things you need to remember.
You can only go up to 2 commands.
You can't have like a lot of cascade commands. That's
So,
the
yeah,
thing.
they say maximum 2. Got one
Like
time
for
they show me
instance,
3.
for
which was
load,
fucking
right? Like
stupid.
the first one, you need to
Yes,
LSL
yes,
in one command. You need to like do the other shit in one command.
Yeah, I know, but
You
that's
need
not
to
the thing
break it up.
that's not the thing I'm referring to.
What are you referring to, sir?
I'm referring to that you might need to remember this C program.
Oh.
Now it kind of
I mean, technically already I see INT main void. I'm like, oh yeah, that's the same thing again.
okay. So the conversion itself, we can go through another day, right?
But I mean, question 4B.
Yes,
4A.
yes.
He wants to go to 4A now.
This one. Yeah. So this one,
I
This-
think calling a function up.
this one itself is actually no. This is okay, but to embed inside a C function, right? To transfer between you know the C function, right? To embed into a C function, ARM instruction or a thumb, or if not within the ARM, right, you can do a thumb instruction, then go back to ARM, correct or not?
Yeah.
Right, is to interchange between the coding languages or the coding, it's actually environment, right? Environment, right? I think it's quite useful because during my exam it came out, and lucky I remember the format, and it actually got quite a bit of things to remember one.
I remember something.
I was watching this lecture when we started.
Okay, I found it. 2021 Sem 2. Okay.
Supposed to give 3 of the initial values, then afterwards you use one of them to compare 2 of them, and then you just add on.
2021, 22 Sem 2. Okay, it's here. Let's look at it.
This is week 12 lecture.
Okay, so let's see. Say they want to facilitate the mixing of C and assembly program, right? So you need to have, right, you need to remember this. Need to memorize. I remember this, okay? I remember this, and then in the exam came out, I wrote it down.
Mixing of C and assembly.
Yeah, and then this is to convert. This is if I'm not wrong, this is inside the ARM program. You need to write this because you can import, export values. Basically, you need to transfer variable in between each other, right? Yeah, this is important. Actually, this is inside your lecture notes.
It's not.
It's inside your lecture notes. If it's not inside, then die.
Wait, I'll take a picture of it.
Oh, okay.
I mean, it's recorded also.
I know, but I will forget to watch recording.
Technically true, that's why I'm not like format.
Let's see when we're
So why do you put all this thing in again every time?
It's called.
Oh.
watch me pull all-nighter number 2 this week.
Powerful. Wow.
So if I pull an all-nighter tonight, I pull an all-nighter on Saturday, and I pull half of an all-nighter on Sunday night, I may be safe for both my exams.
Why is like people like a 3 back to back?
I need a shit ton of coffee. Wait, so in the assembly file you put the preserves export tarata. In the C file you put tarata.
Yes. Yes. It's very annoying, right?
I cannot be bothered to read the entire mess.
When you write,
I just remember it right before I enter exam. And then once I enter exam, I look at the paper and see if there's any C program.
Then
If
you
there's
just sit
I
there
just
and
write
do
it down and then I do other questions first.
wait, so
Yeah.
when you did this, you wrote exclude E all the way to the last part.
So that's extern void in its serial void, extern void XYZ tarata.
Wait,
Okay, got it. I tarata.
underscore serial bracket.
Our main program is written in C program, save as PRC. A subroutine file is written in assembly and save as this. The PRC calls on the XYZ character subroutine. Write a statement in the 2 files to facilitate the mixing of C and assembly programs. So the character.c. I cannot remember the names there, seriously. So you call PRC main calls XYZ S. Okay. Write the statements that facilitate. Export XYZ. Cool. Okay, got it. Thank you.
Okay.
Thanks for the voiceover. You always think to my bridge chat.
So tired right now.
My brain is going like tarata.
I'm not reading now.
Okay, thank you, Anwar. I got it.
Yeah, this is one question that might or might not come out.
Might.
Let's just take the chances of it will.
It's 7
let's go
marks.
to that.
When was this paper?
This is like 2019.
21, 22.
Oh.
Sem 2.
Okay. Actually,
Okay, it might not come out.
it will come out. You know why? When we talk already, it happened.
Ah.
It's like electromag, right? Triangle pop up. I'm like, huh?
Oh yeah, triangle pop up.
Really?
I know it's going to confirm not going to be something simple like square.
I couldn't do it.
But I don't know why. I thought it was going to be like something 3D.
And I remember meeting you by the water cooler and you asked me what's the question. I was like, oh, triangle levitating. The Z equal to D plane.
Fuck yeah.
Okay, are we done for today then?
Yep.
Okay, can we go dinner, guys?
Okay, bye.
We also need to. Do we need to grab the other one?
There?
No, the other one.
Yanni?
Yeah.
You need to know me.
And recording.
Yeah, I'll ask Yan.